everybody coming out. Just a couple of quick announcements, and we have some other folks want to tell you a few things. First of all, you've done a great job so far respecting everybody's boxes and all that, so just keep doing that. I know it's crowded in here. You guys are doing a great job. Just be respectful of people around you when you're working. Trash. Let's be sure and pick up all the trash. If you see something, especially, this is a live airport. If you see some trash outside that's blown away, grab it. Put it in a preferably empty trash can, or not a full trash can so it overflows. But if you guys can help us police that, there's a lot of you. It doesn't take much to get it all picked up, so please help us with that. A little treat today. After the pilot's briefing, we are going to have an aerobatic airplane do a flyby out here a couple of passes and do some stuff for us. So after the pilot's briefing, and not till after the pilot's briefing, you guys all go out onto the ramp right outside the hangar, not down line to the flight line, just right outside the hangar, and you'll get a little treat today before we get started. And with that, I want to introduce Meredith from AIAA. She's your student programs manager, and she's got a few words for you.
Thank you, Russ. As Russ said, I'm Meredith Cowton. I'm the program manager for DBF. And on behalf of AIAA, I want to welcome you to the 2026 fly-off. So it's great that everyone is here. Special thank you to the organizing committee. Russ, you guys have done an incredible job this year. The mission is going to be so fun. Excited to get out on the flight line. Want to say a few thanks to our sponsors who have provided generous support for this competition. Our host, Textron Aviation, Ed Feltrop and his team, absolutely incredible job. Couldn't do without you. We also have our other primary sponsor here, RTX, huge supporter of DBF. We have our gold sponsors here, General Atomics and MathWorks. They're longtime supporters, and we have some new sponsors that we're welcoming to the family with Anduril and Reliable Robotics. We also have our bronze sponsors here, AV, Inc., Divergent, Fiberglass, and NTOP. So I especially want to welcome the live stream viewers. We're live streaming it this weekend, so we're excited that you can join us. And shout out to NASA Spaceflight for hosting the live stream for us. Be sure to follow us on Instagram this weekend. Tag us. We'll do collab requests. And I just want to also talk to the students here. You guys, you're here. You have made it. All of your sleepless nights, the long nights in the lab, reworking your design, it's led you here to Wichita. So you can relax now, take a deep breath. I want you to soak in this moment. And you're here to compete with the best of the best. But I also don't want you to rush past this experience, because years from now, you're going to remember this journey far more than the outcome. AIAA is really proud to be part of that journey, and we don't want it to end after you graduate. So we encourage you to stay involved with AIAA after your graduation. You can join a technical committee, your local section, and start building those connections that you're making here this weekend. So this competition is 30 years old today, which is probably older than most of you in the room. It's amazing to see how much it's grown. So we have a very special guest here today. We have one of the founding members of the DBF organizing committee, Greg Page, and he's going to just share a brief reflection with you, and then we'll have the flight briefing, pilot's briefing with Chris Bovias. So Greg, over to you.
Thank you. Welcome to the 30th Design Build Fly contest. I want to recognize the people who created the Design Build Fly. Design Build Fly organizing committee has always been a committee of equals, and so I'm going to introduce the people involved in the first DBF chronologically, with no emphasis of alphabets or any of that. Design Build Fly was born at what was nominally called the AIAA Spring Conference a long, long time ago. The AIAA has a large number of individual technical committees for which now sponsor and organize and run the Design Build Fly. And almost all of the aeronautical related committees where members were always at that conference every year. So that's the way we were able to actually somewhat serendipitously run into a couple of people that wanted to get this whole contest started. Michael Selig, who unfortunately can't be here today, was a member of the Applied Aerodynamics Technical Committee. I was a member of the Aircraft Design Technical Committee. We had both been talking with our TCs for a little bit about creating a world-class design contest for students to go along with AIAA being the world-class aerospace technical organization. And hang on a second. Sorry there. Michael had actually got things organized a little bit first. He had made an appointment with the Student Activities Committee, which was the interface at the time between AIAA and all students. I had been talking with my technical committee also about starting a contest, but we had never met until that conference. Michael and I met. We gave a joint presentation to the Student Activities Committee. After the appropriate amount of discussion and some very good grilling from the Student Activities Committee, the then chair of the Student Activities Committee, Stan Powell, finally decided to come up and say, stand down and say, okay, you guys have probationary permission to do this for 1 year. And then he had a condition, and he said, and all of the work has to be done by the technical committees that are sponsoring it. He didn't want it to interfere with the other student activity committees. We went back to a second session of our technical committees, briefed them that yes, we had gotten permission, time to get started. Brian Richardet was also on the aircraft design technical committee with me, and he stepped up and agreed to help with me as well. And the formation of an organizing committee was off. When I got back to work, Chris Bavay, who runs all the flight line, you'll hear from him. He's who you really want to talk to next, to tell you about the flying, and I worked at the Naval Research Lab together. And so when I got back, I told him, we got permission, we're going to start this, and he said, well, I'll get the flight test technical committee to join in too. So that gave us the 3 technical committees that started the first year of the contest. An essential person that is not well known to anybody but a few of us that were there, we needed a place for the contest. And Dick Bernstein, who Chris and I both knew through work, graciously loaned me his private island for the weekend. His private island had an airstrip and a house for the judges. And it turned out in the end, he was so impressed with the first year contest, he hosted all of the students to crab cakes and other snacks after the contest. We don't do that after the first year. David Levy was the next member on board with the organizing committee. I don't think David is here today. Okay. He was assigned by Cessna to come out to the first contest. So he was the first sponsor representative on the organizing committee. First contest, we had 12 teams and I think 48, maybe 50 students. We were ecstatic at the turnout of the first year. We didn't become panicked until many years later when we started to see what was created. But we're more concerned with how do we keep this going? In the second year, I was contacted by a member of the Design Engineering Technical Committee. They wanted in on the contest as well, and so they joined, and that became the 4th technical committee, and the 4 that still run the competition till today. From the second year on, the real controller of the growth was not the organizing committee, it was you, the students. The popularity of the contest, the number of students that wanted to attend year after year after year, drove the growth of Design, Build, Fly to what it is today. So I'd like to thank all the founders, and I'd like to thank all the students, past and present. A number of the past are now part of the organizing committee. I hope a number of the present will be in the future. The students are the heart of Design, Build, Fly. So thank you, and enjoy the contest. And the person you really need to listen to very carefully is Mr. Beauvais. He'll take care of everything with you flying. Here you go, Chris.
Thank you, thank you. It's an honor to be here. It's been a long road, and we appreciate all you guys coming here. One of the interesting notes I thought of when Greg talked about Dick Bernstein. He owned a company called AIAA Aerosystems at the time, back in the 90s, built the X-Drone and some other Tiger Sharks and other UAVs back in the day. But he also owned a company called Salisbury Pewter. So that's why, to this day, after 30 years, our prizes, our trophies are round, engraved pewter plaques from Salisbury Pewter. So we keep that lineage, that history going throughout that. So hope you guys can appreciate that for those who get those. I don't know if it's this one. Yeah. All right. Trying to find a position that maybe is better. Check, check. All right. So, here, let's try the other one. Try the other one? Yeah. Try that one. Is that the off? Okay. Try that.
There we go.
Check, check. Well, all right, we'll do this. Less noise. All right. So again, like everybody else said, big thanks to Textron Aviation for the facilities and all the volunteers who are giving up their time. This is still a relatively new facility for us here in Wichita. So please be patient as we work through any traffic flow, communication issues, crowd control. We did have a change this year that where we used to drive the truck, that taxiway is no longer available to us. So the truck will be on the grass, so please be patient as we work through some logistics as we open the flight line. Also stay within the designated spectator area. It is orange paint and cones, so easily visible. We'll keep an eye on you guys to make sure you just stay in that area and be safe. For the contest itself, there are 4 staging boxes out on the flight line. The flight order is posted, and teams are responsible to keep track of the order. The airplane will be brought to the staging box with payloads and propulsion battery packs removed from the airplane. The batteries must be carried to the flight line in a charging sack, and once a team enters the staging area, no adjustments are allowed to the airplane configuration until the time starts. For mission 2, teams will declare the payload to carry. All components and subsystems for loading and restraining the passengers and cargo that are part of the airplane must be inside the airplane. And for mission 3, the banner deployment, towing and release mechanism may be installed, but the banner must be separated from the mechanism. Teams entering the staging box will hand their score sheet to the official. The official will inspect their propulsion battery packs for mission 3, the banner length will be measured and recorded. Only the flight support crew is allowed in the staging box. That's the pilot, the observer, and 1 ground crew. Only the designated ground crew member may work on the aircraft, and only the pilot may be a non-student. Teams must bring all tools, assembly aids, consumable materials such as tape, rubber bands, with them to the staging area. If you forget something, you must leave the staging box and forfeit the attempt. All assembly work on the airplane in the staging box must be done with the airplane on its landing gear. The aircraft propulsion system must be disarmed whenever a crew member is handling the aircraft. Teams must be ready to fly once cleared to the flight line. So make great use of your time in the staging box. Do all the checks you can, because when you get to the flight line, you have to be ready to fly. The pilot and observer can be located anywhere on the flight line, but the start-finish line, there is no takeoff distance requirement this year. The ground crew must remain behind the officials until released by the flight line director. When the aircraft is stopped moving. No chasing of rolling aircraft, and only one warning will be given, then the flight will be forfeited. Aircraft may not begin the upwind or downwind turn until signaled with a raised flag by the pylon judge, and the aircraft must be straight and level when passing the pylon. On all laps, the aircraft must complete one 360-degree turn in the opposite direction of the flight pattern. And the near edge of the runway is a safety line that the aircraft must not cross. You will be given one warning. After that, you'll be asked to land immediately, and the flight will be forfeited. It's a big, wide runway. You don't have to crowd the safety line, please. Aircraft must touch down on the runway for the mission to count. It may roll or slide off the edge of the runway, but it cannot bounce off. Again, this is a big runway. Should not be an issue today. Landings must be parallel to the runway centerline. Aircraft that obtain significant damage during landing will not receive a score for that flight. Please be aware that there is a major road between the northern turn point and overflying that road will result in a disqualification for the fly-off. No warnings will be given. That is Central Avenue here, just north of this hangar. So with the winds out of the south, please be very, very cautious of that. It's a long way away, which is why the flight line is where it is. So be very, very cautious of that, and I will make sure you remind you if you get a little downwind there. Missions must be flown in order, and you must successfully complete the previous mission before attempting the next mission. Okay, so mission 1, that's the test flight. There's no payload, and you must fly 3 laps in 5 minutes. The time starts when the aircraft throttle is advanced for the first takeoff or the attempt. A lap is complete when the aircraft passes over the finish line in the air. The landing is not part of the 5-minute time window, and the aircraft must cross the finish line in the air for the lap to count. Mission 2, the charter flight. Again, payload is passengers and cargo. The mission is the number of laps flown within the 5-minute window. Same thing with the time. Time starts when the aircraft throttle is advanced for the first takeoff attempt. A lap is complete when it passes over the finish line in the air. And the aircraft must cross the finish line in the air for the lap to count. For mission 3, the banner flight, the number of laps flown within 5-minute window will be recorded. After the first upwind turn, the banner must be deployed on the downwind leg of the pattern. After the airplane crosses the finish line on the last lap, the banner must be released. Teams should plan to release the banner immediately after crossing the finish line to minimize retrieval time. Only the aircraft has to cross the finish line in order for the lap to count. The banner does not. Time starts when the aircraft throttle is advanced. And the lap is complete when it passes over the finish line in the air. All instructions from the flight line judge must be followed immediately. Failure to do so may result in a loss of mission attempt, or in the case of multiple or serious infractions, a loss of future flight attempts. After completing all 3 missions, teams will be allowed 1 additional attempt for mission 2 and 1 additional attempt for mission 3. Remember, safety is paramount. People come first, facilities come second, and DBF airplanes come last. We will be monitoring the weather, and we'll advise as things change. There is a storm front, a cold front that's expected to pass through mid-afternoon, so we'll be keeping a close eye on that. We will keep the flight line open no matter what the wind is doing. We will close the flight line for safety because we have electronics out there in the event of rain. But we reserve the right to close due to rain. We'll come back in here. If the rain passes through, we'll go back out and open the flight line again. And that's all I have. If we have any questions.
Must the banner be deployed before or after the 360 turn on the downwind leg?
So the question is, must the banner be deployed before or after the 360-degree turn? Anywhere on that downwind, even within the 360-degree turn. It just has to be deployed from the upwind turn before you do the 180 downwind turn. Okay?
Said the airplane had to be straight and level when it passes the pylon. Where do you mean exactly? What point are you talking about?
So straight and level when we passed the turn plane, and it is not a pylon, there's not a stick out there. There is a virtual plane that is clearly shown in the rules that you have to be straight and level when you pass it, flag will be raised. When you do the 180 and pass it again, the flag will come down. So you turn on the flag, and the flag will stay up, and the whole purpose of that is if the flag goes up and down really quick, if the observer doesn't see it, we make sure we keep that flag up during the turn.
Okay. Also, in the context of really high wind operations, if the plane lands and finds it will roll backwards unless the engine keeps running, what happens then?
Yeah, in the event of high winds, the airplane lands and rolls backwards, you're fine as long as there is no damage to the airplane. Okay? Any other questions?
Doesn't matter what direction we land, whether it's airplane.
So the landing will be done the direction of takeoff. So we will set the flight line pattern based on the current winds. Yeah. All right, if that's it, be my, what? Okay. So right now, landing should be in the same direction as the takeoff. In case of emergency and you have to come around and land downwind, I have no issue with that. But for safety, we want to keep the same pattern. So I'm not sure why, if we have 20-mile-an-hour winds, you want to land downwind. But again, in case of emergency, I'm okay. Just declare it to me that you're landing. Yeah, obviously, if you're running out of power, feel free to land long. If you want to risk doing a 180 with a declining battery to land downwind, that's going to be pilot's choice and pilot's discretion. But prefer to land in the direction of takeoff just for safety reasons. Anything else?
Will the direction of flight be reevaluated based on the winds during the day?
Yeah, always. We will, the direction of flight, the flight pattern is always adjusted based on winds. And it's fairly easy now. When we had takeoff distance requirements, we had a takeoff judge. So it was harder to quickly switch because we had to move the judge from one side of the line to the other. Here, since we have no takeoff requirements, it's fairly easy to switch. But I think based on the current wind forecast, it's pretty gonna be set either from the south or southwest today, and tomorrow it looks like from the north after the front passes. But yeah, always. We've been doing this a long time, and we want to make it safe for everybody. So we appreciate you guys being here. Go get airplanes prepped, get ready. We got tech inspection that's going to be starting, ground missions are going to be starting. We'll get set to prep the flight line. We'll have S-18 doing a flyby shortly, so be aware for any announcements for that. We got another question?
Can you tell us how we're supposed to transition to the flight line from here? We will have this way?
So there is, in the rules, or in the contest information packet, there is a layout of the grounds and of the facility. So the transition will be out to the ramp towards the runway, turn right, stay on the pavement, and then you'll see basically it's a funnel of cones into the grass that will take you down to the flight line. And so please stay within that, again, that funnel of cones, which provides us a safety buffer with the runway and the flight line. All right, thank you much. Appreciate you being here. And I guess we're ready. If you want to go see S-18 flyby, if you want to head out to the ramp, we'll be calling him in shortly. He'll do some smoke passes.
Thorpe, S18, and he is from he's the associate professor of the University of Missouri at Kansas City. He's actually leading one of the teams here from University of Missouri at Kansas City in the Design, Build, and Fly Challenge, and we are just waiting for that plane to fly over to kick off today's ceremonies. Should be pretty fun. Pretty good day today. We got a little bit of clouds today, but good enough for a flyover, The wind is supposedly going to be a little bit of a challenge, but we'll see how these teams deal with this. Okay, so once again, if you're not familiar with the AIAA Design, Build, and Fly Challenge, it is a challenge at the collegiate level where teams build remote control planes that are designed to do a task. If you saw in the opening ceremony, they kind of went over the rules a little bit, but the short story is that you have to build a plane that can move cargo, a plane that can fly correctly, and a plane that can tow a banner around. Each team will have to do 3 different missions. And the first mission is basically doing a test flight, making sure your plane works as intended. Then mission 2 is cargo. And then mission 3 is towing a banner. And throughout the weekend, we will see each collegiate team compete in these 3 missions. Like I said, wind's gonna be a little bit of a challenge. We got a pretty gusty wind today. We'll see. We don't want to blow these RC planes around like a top, but we might see it. I don't know. We'll see some action here. Okay, so once again, we're just waiting for that flyby here in the Mujahid Abdul Rahim in the Thorpe S18, which is, it's an older design. Thorpe hasn't been around for a little while, but they recently started building the kits again. Thorpe S18 is a low-wing, 2-seater side-by-side stunt plane. One of the things about being at an airport, you hear planes, and I don't know about it, I'm pretty sure everybody else here is the same way. We hear a plane and everybody looks. So anytime the airport is not currently active, but that doesn't mean there isn't activity going around today. So if you see me turn and look somewhere, that means there's another plane taxiing around. I'm like, oh. So we're just waiting on that flyby here. There will be 3 passes to this flyby. The first 2 passes are going to be with Smoke. He's going to be booking it, 170 knots to and from on the first pass. And then the third pass will be a nice flyby to kick off the ceremonies here for the AIAA Design, Build, and Fly event. I don't know if you guys knew this. This is the 30th year for this program. It was first started in 1996, as you saw in the opening ceremonies, right? The opening remarks, I should say. It's not the Olympics, right? But it's not every day for this competition, from what I understand, that you get a flyby here. So we're just sitting and waiting here. We'll see what's going on. All the students are out here waiting to see this flyby. And once again, this flyby is piloted. It's not an RC plane. It is piloted by Mujahid Abdul Rahim, who is associate professor at the University of Missouri, Kansas City. He's actually leading one of the teams here today in the Design, Build, and Fly competition. So we're kind of waiting in anticipation. I hear planes moving around. We'll see. Once again, wind is going to be a little bit of a challenge today, but we'll get through it. And once again, we have 1,200 students competing, 98 teams in the Design, Build, and Fly competition. That's a pretty high amount of students. You can see they're all waiting out here on the ramp, ready to go. Coming from 15 different countries, too, on top of that. We got people from all over the world. I believe I saw teams from Argentina. We have teams from Australia. We have teams from Europe. And, of course, a whole boatload of teams here, or should I say plane load, of teams here in the United States. So once again, we're just waiting on that flyby here. This is the AIAA 2026 AIAA Design, Build, and Fly Challenge. And I am EJ, your host. I'll be the master of ceremonies for the next couple of days here.
No and? design, build, fly. Competition, not challenge.
Okay.
Just branding. We call it challenge. Challenge.
Say that one more time.
No and.
Okay.
And it's a competition.
And with that, we have kicked off the 2026 AIAA Design Build Fly competition. There'll be plenty of flights throughout the weekend here from these collegiate teams from 15 countries, 1,200 students, 98 teams. We're gonna have a lot of action here today out at the airport. Should be a good time.
Hi, Russ. I am so glad that you are here today to walk us through this year's mission. I would love to give our online audience some background on what we can expect this weekend. So to start us off, could you introduce yourself and your role with Design Build Fly?
Absolutely. My name is Russ Althof. I've been with the organizing committee for this event since 2007. I started out as the Raytheon representative on the committee, and that was the first year where Raytheon actually was one of the primary sponsors. And I've been the director for the contest since 2017.
Very nice. Yeah. So great. So you have lots of background with DBF. So let's walk the audience through this year's mission. Could you tell us a little bit more about the banner towing bush plane that the students have built this year?
Sure. So each year, when we start our rules, usually in the summertime, we usually come up with a theme. There needs to be a theme around the missions. And this year is the idea that somebody wanted to buy an airplane and start a banner towing business. So, of course, the first mission is he takes delivery of the airplane. The second mission, he's got to pay for it. So he charters flights of passengers and cargo, and that's how he pays for the airplane. And then he makes enough money doing that, he can start his banner towing business. And this year we didn't put in the rules, but we kind of said to ourselves, off the coast of the Carolinas. So that's where it came from. And then, and another reason we did this too was back in 2020, we had a banner towing mission, and we had to cancel the fly off with no warning because of COVID. And we all just on the committee, we want to see the banners fly. So that's why we brought this back, not only for that reason, but also as a throwback for the 30th anniversary this year.
That's awesome. So that was basically the inspiration behind this year's mission. Okay. What do you think the real world challenges of this year's mission is designed to simulate?
Well, in keeping with our themes, we that is certainly the priority of our the reason we do this event. We want to give the students a real world experience in aerospace engineering. So this year they have to, especially for the mission that involves the charter, they have to balance income, which is how much money they get from flying passengers and cargo, against how much it costs to operate the airplane and fly passengers and cargo. And there's a trade-off there, as well as now they can deal with fuel efficiency by picking the battery they pick capacity-wise. So those are the main trade-offs for the competition. And the third flight, certainly the longer the banner is, the more difficult it becomes to stow on the airplane, and then stability of the airplane in flight. And they have to take that into account. But I think the bigger trade-offs come on mission 2.
Yep. What do you think might be challenging for the teams this year that you're going to see in those missions? Do you think it's that third mission with the banner?
It both, really, because we added wingspan as one of the scoring factors on mission 2. And the smaller the wingspan is, the higher their score can be, down to no less than 3 feet. And as you get smaller and smaller, it can get a little bit more difficult to maintain stability. So they have to balance that wingspan with having the maximum number of passengers and cargo, as well as how big of a banner they can pull. The longer the banner, the more score, but the smaller the wingspan, the more score, and those might contradict a little bit.
Yeah. Yep. So turning to the reports, having looked through all the reports, was there anything in there that surprised you?
There always is. We always try to anticipate what teams might do with the rules we give them. 2 things jumped out this year as we started looking at the reports. One team is claiming 144 ducks as their passenger capability. We'll see.
That should
And
be
then
interesting.
another team said they have a 30-foot banner, and I think we saw it on Instagram maybe or something, where they actually said they flew with it. So it's always, we see what's in the reports. When it comes down to building the airplanes, testing them, and then they bring them into tech inspection, sometimes reality hits and they don't really do that much. But always something like that on the payloads that jump out at us. In fact, when we saw that number of 144 and several around 100, we actually went and bought more ducks just to make sure we had enough. So
That's awesome. So we should see a lot of ducks flying this weekend.
hopefully they stay in the airplane, but you
A lot of
never.
ducks. Yep. What is your favorite part of the competition?
Camaraderie among the students. That as always stands out. Somewhere in the competition, something happens and the teams all come together. A lot of times, some of the foreign teams might have trouble getting visas, or it just costs a lot of money. They might show up with just 1 or 2 people, and the other students all jump in to help them. Never fails. For me personally, I like it when sometimes they fail. The mission fails, they crash, there's something doesn't go as they expect. And if I'm there, I try to walk through, well, what happened? And point out, maybe if I can, I'm not an expert, but sometimes it's real easy, here's what happened. And you see that light bulb go off in their head, like, oh, we didn't think about that. They learned something. That's one of my favorite parts, because we're here to learn, not to have an RC airplane contest. And so when that happens, that's always the best part for me.
Yeah, I love that. That is awesome. Do you have any final thoughts or advice for our competitors this weekend?
Sure. So DBF has grown quite a bit in popularity. We have a lot of teams and a lot of students in a limited amount of space. And so just please be patient. We have worked very hard over the last several years to accommodate as many teams and to make sure we have as much opportunity for each team to get their missions in as possible. We have streamlined everywhere we can. In Wichita, the weather's always kind of iffy, so just be patient. We will do our absolute best, and when it's your turn to go, be ready to go.
That's awesome. Yes.
Yeah.
Hopefully patience will be abundant this weekend.
Yes.
So I'm really looking forward to the fly off and seeing how these missions actually show up at the flight line. So we certainly have a lot to look forward to. So I will see you on the flight line.
All right. See you there.
See you there.
At General Atomics, not only do we make remotely piloted aircraft, we engineer innovation. For over 30 years, our Predator, Reaper, Gray Eagle, and Avenger aircraft have offered long endurance, flight-proven performance, and versatility. Today, we continue to develop and manufacture state-of-the-art, remotely piloted aircraft, tactical reconnaissance radars, and surveillance systems for the U.S. Department of Defense and many of its allies across the globe. Electromagnetic Systems is a world leader in applying advanced technologies to launch and recover aircraft aboard carriers, as well as transforming innovative concepts in breakthrough surveillance and electric weapons systems. Our scalable satellite platforms support defense, civil, commercial, and academic mission requirements. From underwater to space, we support the future warfighting force. Since the dawn of the atomic age, General Atomics has advanced the full spectrum of science and technology. From nuclear energy and defense to medicine and high-performance computing. Because of our people, we continue to leave a legacy of exploration and innovation. Tasked to produce the center solenoid for the International ITER experiment, General Atomics has been entrusted to develop the world's most powerful superconducting electromagnet. Perfecting nuclear fusion in this lab demonstrates the feasibility of fusion power, a potentially limitless source of clean energy. With the freedom to explore, General Atomics delivers transformational technologies for the world. Innovation made real.
So my main project this summer has been working on interceptor reliability. What we're doing is we're trying to make it so that the battery on our interceptor can be hot swapped in the field without requiring additional calibration. So this is our flight cage. This is where we do all of our testing and preliminary flights for the drones. This is our dyno. This is where we secure the drone so that when we spin up the motors, it doesn't go anywhere. All right, so I'm running our interceptor on the motor dyno. What we're doing is it spins the motors, which spins the propellers up, and then from there it collects the data of what the motor offset values are, and then it calibrates it so that our interceptor can have its optimal performance. Working at Anduril is different than working at any other company, mainly because of the autonomy I have as an intern. I feel really empowered by my mentor and my manager to kind of do what I need to do in order to get my work done that week. It's also a lot different than other companies because I can see how my work as an intern over the summer directly impacts the company as a whole.
In aerospace, losing a major contract doesn't just mean missing revenue. It can shutter an entire division. Billions in potential business, gone. Because you don't get second chances to prove your design works. Traditional advanced design forces you to choose between speed and fidelity when both are critical. NTOP changes everything. Explore hundreds of design variants with high-fidelity physics in the same time as it used to take for basic estimates. With implicit modeling, you can create robust parametric models that never break, so you can quickly generate any possible configuration of your design and get near real-time performance calculations that enable deep trade space exploration and generate high-quality performance data at a pace aligned with project timelines. Arrive at design reviews with comprehensive trade-off analysis instead of rough approximations. Because in a world where billion-dollar contracts are won on technical credibility, low-fidelity insight isn't good enough. When you're asked tough questions, you'll have real answers backed by real data. NTOP. Design with confidence.
We are scientists and engineers. We are technicians and thought leaders. Collaborative, inspiring, innovative. Advancing aerospace and defense with a bold vision for the future. We are here to connect and protect the world. Powered by purpose and driven to make a difference. We believe no challenge is too great, no question too big, no answer out of reach. We believe in pushing the boundaries of known science to meet the needs of the future. We believe in the power of people, the strength of community, and the importance of freedom. With passion and purpose, we shape the next era of aerospace and defense to create possibilities for better tomorrows. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX.
Okay, welcome back to the AIAA Design Build Fly competition. I'm here with the flight line commentator, Chris Horton, and we have already had flights getting ready to go. So, Chris, who's flying first?
Up in the air right now is the University of Southern California. This is team number 1, and this is our first mission.
Cool, all right, so I believe the flights have already gotten underway, so let's go see what's going on. Oh.
Pronounce that again for me, Ljubljana. Next up now is the team from the University of Ljubljana, and this team number 2, and it's their first mission.
Okay, we've already done 2 flights here. Chris, who's the next team that's up?
Next up is from Australia, from RMIT. It's team number 3, and they're flying their plane, the Thunder Duck.
The Thunder Duck. All right, let's see what we got. They're putting it out on the runway now.
And that was a cool flight from the last team.
Yeah.
They had a lot of tricks and everything.
That windage really is going to be a challenge today.
It is going to be a challenge.
Absolutely.
The wind's going to pick up today, too.
Yep. Okay, let's see what we got. They're going out onto the runway now.
Okay, we just saw flight number 2 for the day, right?
That was flight number 3 for the day. And
Flight
that
number
was
3.
Number 3, and that was actually Notre Dame that went up, team number 4, and they were flying their Duck of the Irish plane. Now we've got the team from Melbourne coming up from Australia with their plane, the Duck.
The
Thunder
Duck.
Duck.
All right, let's go see. Once again, those winds. Challenge, proven to be a challenge today, but we'll see. They're getting ready to take off now. Okay, time for the 5th flight here. That flight was actually pretty good. They dealt with the wind pretty well. Who do we got coming up next, Chris?
Next we've got Georgia Tech on team number 5, and they're flying their plane, the Buzz Array.
The Buzz Array. All right, I love it. It's a great name. Okay, so we'll see. They're actually setting up. That's them over there, right?
Setting up now. No,
Yep.
yes, they are.
They're just setting up now. So yeah, they'll be out on the flight line here momentarily. Once again, this is the AIAA 2026 Design, Build, Fly competition. In Wichita, Kansas. That's right. Now, just in case anybody's wondered, these planes are RC controlled. They are controlling them out on the flight line with an RC controller. The thing is, though, is that we got some nasty winds today. 20 knots.
20 knots, right?
Yeah,
already.
that's going to be a little bit of a challenge for the team.
We got some weather coming in too.
Oh, angry clouds. We got angry clouds coming, but yeah, we'll see what's going out on the flight line here, and the next team should be getting ready to go up right now.
like this one here is up next, the one next to me. Yep, they just did an engine test. Watch your step there. Yep. Thank you.
Okay, we got the next flight ready to go. Chris, who do we got?
We've got the University of Kansas, go Jayhawks. This is team number 6, and they're flying their plane, the Icarus.
All right, Icarus. So this time around, I'm going to leave Chris behind over here. I'm going to go see what's going on up at the flight line, and I'll commentate on this one. So, Chris, I will see you back here in a little bit.
See ya.
Okay, team. Too close to the sun. Let's see. All right. We got to take off. And that wind's nasty up. Once again, Mission 2 is on board. Hockey Pop. That will be the name of my next band. All right. And then Mission 3 will be... Once the plane, the judges are going to judge here. Coming through here. Looks to be on approach here for a landing. She's coming down. Counter that wind there. It's into the ground, but Icarus is back down on the ground. Once again, that wind is it's really tough. considering the circle. Okay, that flight got a little rowdy on landing for Icarus there, but what's the next flight we got, Chris?
The next flight is team number 7, hailing from my alma mater, the University of Texas at Dallas.
All right.
And they're playing the Leviathan.
The Leviathan, all right. Let's see if she can move through the wind
Closer.
like that. Okay, we are go for takeoff. Let's see what we got. And once again, I'm gonna be trying to commentate this again, just a little tricky with the wind here, but we got this. Okay, we got the Leviathan taking off here. Here we go, right up into the wind. Now once again, these are just test flights. This is mission 1 in the design build fly competition. Mission 1 is just a flight test. Make sure your plane's qualified to do the task for mission 2 and mission 3. But yeah, those winds that are just a little bit up, probably about 200-300 feet up, are getting a little tricky for these RC planes, but the Leviathan seems to be living up to its name here. It's cutting through that air just fine. All right, nice steady flight coming from Leviathan there. Good job. That thing's cutting through the air, no problem. Now, what mission 1, what that flight plane entails is just going up. There's 3 indicators on the runway. There's the center line, and we basically have an oval here. 500 feet down one side of the runway, you have a turnaround gate, and 500 feet down the other side of the runway, you have another turnaround gate. And we're sitting here, dead center at the start-finish line. It's basically like a short track. Go down, go fast, turn left, turn around, go left, turn around, coming down and land. Once again, just a flight test to prove that these vehicles are up to task for mission 2 and mission 3. Okay, that thing's flying perfectly straight. Perfectly straight. The wind does seem to have died down a bit, to their credit, but I'll tell you, up there, it's still moving that thing around. Okay. There we go. And then on the center side of the, so like on the opposite side of our start-finish line, you have to do a little bit of a loop there. Not a loop. You have to do a 360-degree turn to get to the last gate, and that's what you see there, coming around on the final turn here. Okay. Pilot bringing that thing in for a landing. Oh, oh. Once again, had a little bit too much airspeed coming in. All right, let's see. Attempt number 2 here. Okay. Throttling back on the engine there. And a nice soft touchdown. Great flight. All right. Okay, that was a really good flight from the Leviathan at UT Dallas, but who do we have coming up next, Chris?
Next we've got our team from RPI, it's team number 10, and they're flying their plane, the Koi.
The Koi, all right. See if she goes like Koi through the pond. All right, they're set up on the runway. Let's go see what we got. Test. Testing. All right, RPI landing the koi. Koi swimming through the air perfectly there. That was really good, really good. Should be up here with the next team momentarily. In fact, they look to be getting ready to go. Look to be getting ready to head out there now. Just wait momentarily. There's a little bit of flux in the staging lines here. Once again, we got 4 staging lanes here for 4 teams to get ready to do their flights. Of course, it's as they're ready. You know, kids got to get these planes ready to go, and they have to bring them down here from the hangar, get them staged and ready to go, ready for these pre-flight tests. Once again, mission 1 is just a flight test for these planes. It's just to make sure that these things can take off, fly around, and come back. The planned flight is basically, we have more or less a circle track here. So they take off on one side of the runway, they go down about 500 feet, turn around, come back about halfway down the other side of the runway, do a 360-degree turn, and then go down to 500 feet further down the runway to do their left turn back onto the quote-unquote main straight here. So next team's getting ready to go. Okay, Chris, who's the next team that we got here?
Next up is the University of Washington, Seattle. It's team number 9 flying their plane Mako.
Okay, Mako. Interesting design there. Looks like we got a contra-rotating propellers there, if I'm looking at that right, and a V-tail. It's the first plane I've seen with a V-tail today. All right. Okay, teams are clearing off the runway here, getting ready to fly. That wind today is real nasty, so that's why we still got one out there holding that plane. Okay, the student makes the final checks there. Okay, here we go. Okay, so once again, this is the University of Washington at Seattle firing up the engines on their Mako entrant there. Wind taking that thing right up into the air. Once again, this plane is utilizing contra-rotating propellers, meaning you got 2 propellers up at the front of the plane. One is spinning counterclockwise, the other one's spinning clockwise. The idea there is that you can get more thrust from the 2 propellers because essentially one feeds the other. Like, I know it's a little bit more complicated than that, but that is the gist of the idea there. They're circling around through turn 1, going through the 360-degree loop around here. All right, looks to be handling that loop really well. Okay, circling around, turn 3 and turn 4. Coming back out over the main straight. Oh no, it seems to be getting into some windage up there. It's where the wind speed and the airspeed on the plane are basically the same. Plane seems to hover in place. Those winds up there are really taking the plane. Oh, It's going up in the air, coming back around for turn 1 and turn 2 here. Okay, coming around, turn 1 and 2, looping around again. Look at, now the plane's got that tailwind, really pushing it forward more. Get a lot more ground speed with that tailwind there. Okay, did the 360-degree loop around, coming down through turn 3 and 4, looping around. Once again, turn 1 and 2 are 500 feet down from the start-finish line. Turn 3 and 4 are 500 feet in the other direction. And there we go, there's that headwind holding that plane in place. Okay, crosses the start-finish line. Going into turn 1. Okay, circling back around. Turn 1 and 2, doing that 360-degree loop. You could really see that wind up there is picking that plane and tossing it around, but seems to be doing okay. Going around to turn 3 and 4 here, looping around. Oh, there's that headwind again, around off of turn 4. We got a nasty headwind. That plane is staying right still. But it's powering through. Once again, I just want to remind everybody, this is mission 1 of a three mission kind of docket of flights that these teams have to do here. Mission 1 is essentially just a flight test. You just got to prove your plane can fly. That'd probably be a good requisite before you start moving cargo and crew around, because that is what mission 2 is. Mission 2 is moving rubber ducks and hockey pucks. That will be the name of my future progressive rock band. Now, oh man, that headwind is really taking it again. And then mission number 3 is towing a banner around. It's going to be tricky with that wind, but coming in to negotiate a landing here. And once again, that headwind is really nasty on coming out of 3 and 4 on the runway here. Once again, the plane appears to be hovering because the wind the wind is blowing over the wings and causing lift, and it's basically holding that plane right in place as they touch the plane down. Oh, a little bit of a bounce. Okay, which comes back down in one piece. Any landing you can walk away from. It's great. Fantastic. Fantastic. So Chris, what team was that again?
That was the flying their plane Mako.
Mako, that was great. That was a great flight from them. All right, so looks like we got another Mako out there, Chris. Who is that?
That's the team from Virginia Tech, go Hokies. That's team number 11, and this is their first flight of the day.
Okay, and they're also named Mako.
We got 2 Makos up in.
I'm sitting here thinking we messed up again, but no, there's in fact 2 Makos here.
We've never messed up at all.
No, we're great. Okay. Virginia Tech with Mako getting set up at the start-finish line here. Team's out there making some final adjustments to the plane before flight, doing some final pre-flight checks as the Mako's about to take to the sky for Virginia Tech. We got winds coming out of the south today, 20 knots, gusting up to 27, but at higher altitude it seems to be a little more rowdy up there. There we go, Mako takes to the skies. Okay, once again, we have basically a short track here. Plane has to take off. We're at the start-finish line. You get to turn 1 and 2, which is 180 degrees combined there. Turning the plane back around. And when you're halfway through on the backstretch of our proverbial short track, you got to do a 360-degree loop. Mako seems to be negotiating that pretty well. And then on to turn 3 and 4. Turn 3 and 4 is real tricky because that's when you're going right into the wind. So the airspeed's going to try to slow you down. Or the wind is going to try to slow you down here. We got Virginia Tech and Mako really utilizing the old moniker that altitude is your best insurance here. Going around turn 1 and 2, coming through the 360-degree turn on the back stretch. Okay, seems to negotiate it just fine. Coming around turn 3 and 4, right into that headwind. And of course, you got a headwind coming into 3 and 4. That means you got a tailwind coming out of 1 and 2. Your airspeed's, or your ground speed's really going to increase coming off turn 2 here. So as the Mako turns around again, see the plane really starts to speed up, really starts to move while you're on the backstretch of our track here. Doing the 360-degree turn, there we go. Now turning around, going into the headwind. Okay. All right. Mako turning around onto the main straight. It seemed to be trying to negotiate in a landing. Once again, that plane is way up in the air. So again, the Virginia Tech pilot utilizing altitude being the best insurance here. These winds are very tricky today. We've got a lot of gusts. Okay, lined up on an approach here. Okay, there we go, right into that headwind. It gets a little bit tricky. You got to keep airspeed over those wings or else you don't want to stall out. But with the wind, it shouldn't be too bad. There we go. All right, Virginia Tech and Mako back down safe on the ground. Well done, well done. Okay, and as Virginia Tech vacates the track, we will have another one coming on real quick. Chris, who do we have up next?
Up next is our team number 14 from the Universidad de Antioquia in Colombia, flying their plane, the Scorpion.
All right, Scorpion, I love the name, let's go. Okay, once again, this is an international competition. We got teams from 15 countries. We've got 1,200 students here, 98 teams. This is an international competition, so it's not just the United States here. Okay, they're getting ready to move out of the staging as Virginia Tech moves to the Mako.
Can I throw in a little plug?
Go ahead.
Hey, while we're here, we've got a few minutes, I want to give a special thanks to Textron Aviation Employees Flying Club for hosting us out here for the next 3 days.
They've been pretty nice to us.
Yes, they have been.
Dealing with us, right?
Exactly.
They've been pretty good. Okay, here we go. Scorpion moving out to the pad. Moving out to the pad runway. Okay. So the interesting thing there that I'm noticing from the Scorpion is that it's utilizing tricycle landing gear. The last couple of planes that we've seen have all been tail draggers, where you got two main gear up at the front and you have your small gear at the very back end of the plane, dragging the tail around. This is utilizing tricycle landing gear, meaning you got a small gear up at the front of the airframe and then two main gear right around the center of gravity. Tail draggers are really popular kind of at the dawn of aviation. They're still around. It's still an oldie but a goodie, but most modern airplanes are utilizing tricycle landing gear. Let's see if that pays off with these winds. Tricycle landing gear means you can rotate on the runway. You can rotate the entire fuselage of the plane on the main gear. That's what most modern jet airliners utilize, being able to rotate on the runway. With the tail dragger, that gets a little bit tricky. You got to get your airspeed up, you got to get the tail up in the air, and then you got to try to rotate off the runway. But we will see as they're getting ready to go here. All right, engines are on. There we go. Scorpion takes to the skies. Okay, coming down to turn 1. Once again, we got that headwind, and when you turn around, you got a nasty tailwind that's going to really accelerate that plane coming off of 2. Scorpion doing the 360-degree turn here. Coming down into turn 3. Actually seems to be quite stable. All right, coming off 3 and 4. Back into that headwind. Oh, a little turbulent up there. Once again, I don't know if this is a meta that they're using, but everybody seems to be flying high up in the air. That might be the wind just taking that plane up there, but it also might be, you know, if wind's going to push the plane around randomly, you don't want it near the ground because you don't want it to push itself into the ground. There you go, Scorpion doing their 360-degree turn on the back stretch of the track, coming through turn 3 into turn 4, into the headwind. Once again, this is mission 1 of 3 missions that these teams that these teams are competing in. Mission 1 is basically just the flight test. So we're going to see the plane just do a couple laps around our track here. Now that's just mission 1. Mission 2, when that comes around, is going to be a cargo mission, cargo and passengers. Our passengers, though, aren't people. These are our seaplanes. They're just rubber ducks, just as important. And then we got hockey pucks for cargo. So it's very interesting how, you know, teams don't have, you have to move a minimum of 3 ducks and 1 puck, right? So it's very interesting how that's driving the design requirements for every team. You see some teams that you have a minimum amount, but some teams can move more ducks, and the more ducks you can move, right? More ducks you can move, the more points you can get for those cargo missions. But once again, none of that is happening right now. What we're looking at is mission 1 here. Mission 1 is just a flight test of the vehicle to make sure it can perform mission 2 and mission 3. Now mission 3 here is a banner, dragging a banner around. If you've ever been out on the beach, you see a plane that's dragging a banner with a sign that says, you know, it's real estate, right? That's what the 3rd mission is. But here we go, Scorpion's coming in for a landing. See if that tricycle gear pays off. All right, perfect. That was actually a really good landing. Once again, great flight from the Scorpion there. All right, and as they move out, teams seem to be pretty dang happy with that one. And that thing, when it came in for a landing, it was able to utilize that rotation that I was talking about. And that rotation clearly paid off. Plane's down in one piece, crews taking the plane off of the runway pad. Smile and wave into the camera. Okay. Chris, now who do we got next coming up here?
Coming up next is team number 13. They're coming from UCLA in California, and they're flying their plane, the Duck Duck Goose.
That's a great name. All right. UCLA with the Duck Duck Goose. All right. Teams are moving out to the runway now.
Yeah, he's the RC cop.
Okay, once again, the wind is really nasty coming out of, you got a very nasty tailwind coming out of turn 2, but for takeoff, you got a nice headwind. So actually what that's gonna do is gonna make these planes take off in a shorter distance here, because the airspeed moving over the wings, all you need is a certain amount of airspeed moving over those wings to generate enough lift to take off. That doesn't necessarily mean you need to be going fast relative to the ground. And once again, the UCLA is utilizing that tricycle gear again. They have 2 main gear underneath their wings, right, and a smaller gear right up at the front. But it's kind of interesting thing to note there. They are running winglets on the, well, it's kind of a wing fence on the end of those wings there. That's to make airflow over the wings a little bit better so it doesn't cause as much drag. Another thing that seems to be going there from Duck Duck Goose is that they have a very long tail on that plane. So long tail, longer fuselage will favor more stability in flight. Let's see if that pays off for them with the wind. Okay, engines are on. Here we go. Duck, duck, goose. See? Right up into the air. There it goes. Okay, going into turn 1. Coming into that tailwind now. Plane's going to really speed up relative to the ground. Okay, doing the 360-degree turn, fighting through that wind, but that long fuselage is really favoring the stability here. Okay, turn 3 into turn 4 here. Now back into the headwind. All right, it's really powering against that wind there. Now once again, the motors on these planes have to be electric, but I don't think you got a certain limit on batteries, but I'm wondering if that, you know, the power, depending on what engine you use, is going to obviously favor your design or not favor your design. You're going to need some quote-unquote horsepower to really power against that headwind with the tailwind. Look at that thing fly. Going through 360-degree turn on the back stretch of our track. All right. Coming up into turn 3, right back into the headwind. Now the plane's really going to slow down. Once again, we have a nasty headwind, 20 knots, coming from the south here, gusting to 27. That really is going to blow these planes around, but these pilots seem to really have a good fundamental understanding of this. Once again, I see the UCLA, I'm not sure if this is just, you know, a meta that they're trying to do, or if that's all, you know, just the wind blowing the plane up in the air, but everybody seems to be a little bit higher up off the ground, give themselves a little bit of insurance. You don't want the wind to blow the plane around and have it nosedive into the ground, which seems to be what we saw from an earlier team doing the 360-degree turn, coming into turn 3 into turn 4 here. Once again, back into that headwind. Trying to bring the plane back down. That headwind really wants to keep that plane into the air, or up in the air. Okay, they're circling around. Okay, circling around here, trying to line up a good approach. Okay, trying to bring it on home. UCLA's trying to bring her down. Looks to be a good approach, but that's a nasty headwind, I tell you. There we go. Look at that, the engine, they're throttling the engine, they're feathering that throttle, the plane doesn't want to come back down. She wants to keep flying. Yep, go around, take off, go around there from UCLA with duck, duck, goose. That's the right move. That is... That's the right move. Always go around. You never try to commit it to a landing you're not comfortable with. That's a great move by the pilot there. Okay, lining up the approach again. Once again, that wind wants to keep that plane up in the air. Because it's not about how fast you're going relative to the ground. It's about how fast the air is moving over the wings on the plane. If your plane needs 20 knots to take off, and you turn it into the headwind, it'll just take off. You don't need the engine to go. But duck, duck, goose comes down. Nice landing. Very good. It looks like the front of that tricycle gear came off. Looks like they lost it. But recovery team / pilot is going to get it and bring it back. There we go. So once again, that was UCLA with duck, duck, goose. Very, very good flight there. Good flight. Okay. All right, we're going to take a quick 5-minute here between flights, but we will be back momentarily. Once again, this is the AIAA 2026 Design, Build, Fly competition.
watch it. Southwest, and they're moving northeast. Okay.
Okay, the next team is up. Chris, who do we got?
We've got team number 15 hailing from Auburn University at Auburn, flying in their plane AU-26 Independence.
AU-26 Independence. That's going to be a mouthful during this commentary, but I think we can handle. Okay, team's getting out there. Ready to go. Once again, with past two that we've had here, we're tricycle landing gear. This one is another tail dragger. All right, teams are getting ready to fly here. All right. Pilot communicating to the ground crew that they are ready to go. Judges are ready to go. Let's see what Independence has for us. Okay, engines are on. There we go. Okay. Independence going through turn 1 and turn 2, looping around here for the 360-degree turn here. Once again, the track that we have is more or less an oval, but on the back stretch of that oval, we have a 360-degree turn built in. The thing is that really, it's going to put the plane through its paces because we have a pretty nasty wind coming out of the south, 20 knots, gusting to 27 from the METAR report. From the airport. The benefit here is that we're on the airport. We got the METAR. We know what the weather's going to be like. But that makes for pretty challenging conditions, especially during this 360-degree roll, because half of it you have a tailwind and half of you have a headwind. That does definitely put some stress on these planes. But there you go, coming around 3 and 4. Independence going into the headwind here, crossing the start-finish line. Again, it seems like the winds up there seem to be a little bit more rowdy than the winds that we have down on the surface here. There you go, coming out of turn 2 there. Turn 1 and turn 2. Now we got the tailwind. Tailwind halfway through that roll, headwind, and then back to tailwind again. That's why these planes, when they're trying to do that roll, seem to be doing a decreasing radius when they get 180 degrees through. All right. Oh, it's getting a little hung up there. Oh man, that headwind's really tricky. Pilot's trying to get downrange of that runway so he can get a good approach. It's really tricky when coming for approach on that start-finish line. The reason why that headwind is going to keep that plane flying. Mother Nature wants to keep the planes up in the air today. Okay, coming in on approach here. Once again, with a plane, it's not necessarily about how fast you're moving over the ground. It's how fast the air is moving over your wings. If the wind is enough to make the air to generate lift, if the airspeed is enough to generate lift over the wings, the plane's going to keep flying. But that doesn't seem to be a problem for them as they land Independence back down. There we go. Oh no! Oh, see what I mean? Oh, but Independence seems to be intact there. Crew's going out, running out pretty frantically. They don't want it to take off again. All right. And Chris, who was that again?
That was Auburn University at Auburn, team number 15.
All right, team number 15. We're already 15 flights in. Not bad. Making pretty, or that was team number 15.
Yeah.
All right.
A little out of order.
Everything is always in flux here, but the next team is making their way out as Independence and Auburn come off the runway. Who do we got next?
Next, we've got Purdue University, team number 16, flying their plane, the Quack Eddie.
Quack Eddie. I love these names. These names are great. Okay, once again, we got another tail dragger, but Quack Eddie seems to be utilizing twin vertical stabilizers on the back, similar to B-25 Mitchell. If we're going to go with an oldie but a goodie, I'd say. Or a B-24 Liberator, depending on what size bomber you like. But unlike those planes, which were both tricycle landing gear, this one is a tail dragger. So note the tail is low to the ground there, and their main landing gear are up at the front of the vehicle. Okay. Okay, teams are getting ready. Here, pilot moving over to the flight line. Once again, they're having somebody stay out there and hold that plane in position so it does not take off before they're ready to take off. Okay, there we go. Quack Eddie takes to the skies. Okay, once again, this is Purdue here with Quack Eddie going through the 360-degree roll. Now they seem to, on top of those twin vertical stabilizers, they seem to have two-engine design. I believe this may or may not be the first twin engine that we have today. Okay, there's that headwind again coming out of 4. It's nasty. It wants to keep the plane up in the air. There we go. Seems like Purdue seems to be a little bit lower to the ground than past competitors. Once again, we're not sure if that's a strategy that the teams are employing or if the wind's just pushing that thing up in the air. Coming around, turn 1 and 2. Once again, now you got a tailwind. That's when your ground speed's really, really going to increase as you go into the 360-degree turn here. Now, once again, this is just mission 1 of 3 missions throughout the weekend that these teams have to accomplish. Mission 1 is just a flight test. We have our kind of racetrack here, so to speak here, where it's more or less an oval with a 360-degree turn on the back stretch, right? They got to do 3 laps here and they got to land it. They only can do it in a certain amount of time. So it's important to execute these laps and then get that plane back down onto the ground. Definitely makes for a little bit of a challenging condition with that headwind. Okay, circling around 1 into 2 here. Now switching back over to the tailwind. The ground speed's really going to pick up. Okay, going through the turn. All right, there we go. Purdue taking Quack Eddie around to turn 3 and turn 4. There we go, back into that headwind. They're really going to have to hit the gas to power through it. We just had a nasty gust of wind. Okay, Purdue's bringing her back down. On approach. And there we go. Very clean touchdown there. Perfect. Well done. Recovery teams are now moving. Recovery teams are now moving to get the plane there. There we go. Crews are out there safe in the plane, bringing it off the runway. Okay. Now, Chris, who do we have teed up here?
Coming up next is our team from Bangladesh, India, at the Military Institute of Science and Technology. It's team number 17, and they're playing the Heisenberg.
The Heisenberg. That is a great name. All right, let's see, once they get that plane out on the runway, let's see if they cook. Let's go. Once again, this is it's an international competition. We got teams from 15 countries here, 1,200 students, 98 teams all over the world coming in to compete in this, the AIAA 2026 Design, Build, Fly competition. Okay. Now, Heisenberg is utilizing tricycle gear again. Once again, the small gear is up at the front of the plane. We got an engine up at the front, and you got your main gear under your wings, under the main wings, as opposed to the other wings. No. So let's see if that favors them during that takeoff. Once again, we got a pretty gnarly headwind here at the start-finish line. It's about a 20 knot wind, give or take, and that really makes for some challenging conditions here. Okay. All right, Heisenberg is ready to go. Okay, Heisenberg takes to the air. Okay, once again, battling that headwind. Judge down at the end of the runway signals that it's good to go through turn 1 and turn 2. Heisenberg turning around, getting that tailwind, increasing that ground speed. Okay, 360-degree turn from Heisenberg. Here, going into turn 3 and turn 4. Now, when that plane turns around, comes out of 3 and 4, you're going to go right back into that headwind. That the ground speed is going to slow down. There you go. Okay, battling through, getting down to turn 1, powering through that headwind. That headwind is nasty. It is pushing that plane around. But Heisenberg is an experienced pro, seems to be dealing with it. Okay, going into the turn here. Okay, seems to negotiate the turn on the backstretch, 360-degree turn on the backstretch just fine. Coming into 3 and 4 here. Once again, turning into that headwind. Makes for a pretty challenging condition here. Once again, the headwind is going to push more air over those wings. More air is going to generate more lift. And if your plane can take off in 20-knot winds, well, it's a little bit of a challenge to get that thing back down onto the ground. Okay, negotiating 360-degree turn again. Oh man, the wind really pushing that plane around. Okay, coming into 3 and 4, turning around into the headwind, back onto the main straight here. Oh man, headwind really pushing that, well, pushing that plane not backwards, but kind of stationary. Okay. Once again, pilots circling around here. They've completed their 3 laps. Now it's just down to trying to get that plane back down onto the ground. Okay, here we go. That headwind appearing to keep that plane right in the same spot. And oh, all right. Say their name. Heisenberg. He's back down on the ground. Great flight, great flight. They turn it around, the tailwind's trying to take it, but it's coming back over. Look at that, they even taxied it. There you go. All right, as they exit the runway now, who do we got up next, Chris?
Next up, we've got our team number 25 from Santa Clara University in California, flying their plane, the Wings of Theseus.
These names are fantastic. Wings of Theseus from Santa Clara University in California. All right. All right, they're going to be moving out here in a moment as Heisenberg from Bangladesh is vacating the runway. Yeah. Okay. Team's moving out to put Wings of Theseus out onto the runway. Okay. Pilots are moving into the flight line position. Okay, teams are away from the runway. Let's see what we got here from Wings of Theseus. And with a name like that, I can't help but wonder how many times they replaced the wings on this plane. Okay, once again, utilizing a tricycle landing gear, Wings of Theseus is up in the air. Powering up against that headwind there, moving into turn 1. We're getting some, looks like a little bit of side slip from the plane. Going into turn 1 and turn 2, Wings of Theseus coming around onto the backstretch of the track. Now you got a tailwind. Now that plane's ground speed is going to speed up. Doing the 360-degree turn on the backstretch of the track. Okay, seems to have negotiated that turn coming into 3 and 4 here. We got an okay from the judge that they've gone through 3 and 4 correctly. And once again, they got to do 3 laps. These 3 laps are part of mission 1. All right, so we're doing this all weekend. We got Friday, Saturday, and Sunday, but each team has 3 missions to complete. Mission 1 is what you're seeing right now. Now, mission 1 is just a flight test. Make sure that plane can fly. And Wings of Theseus seems to be doing a good job of that right now. Going down to turn 1 and 2. Now, mission 2, once you prove that you can fly, is moving around cargo and crew. We got rubber ducks and hockey pucks. Hockey pucks being the cargo, rubber ducks being the crew. You have to carry a minimum of 3 ducks and 1 hockey puck here. But you can carry as many as you want to gain more points. Now that's the cargo mission. Now you got to do the same thing with the cargo. Mission number 3 for these teams is pulling a banner around. Make sure you can tow a banner and fly around correctly with a banner tugging on the back of the plane. But once again, those are the missions that these teams will be encountering throughout the weekend. What you're seeing right now is mission 1. It's just a flight test. See if you can negotiate the track here. And Wings of Theseus seems to be doing a good job doing that here today. Oh man, that is some nasty side slip going on right there. But she's powering through it, circling through 1 and 2. Onto the back stretch of the track. Going into the 360-degree turn. Okay, negotiating the 360-degree turn correctly, coming around 3 and 4. Now back into that headwind. It's really where the plane's going to have to power against that wind. Once again, we got a 20-knot wind that's coming out of the south, and south is the way that the plane is facing right now. It's powering through that headwind. Okay, pilot opting to go around. Once again, you only have a certain amount of time to complete 3 laps and land out there. Okay, coming around for another approach here. All right, the wind is keeping that plane up in the air. Okay, pilot choosing to circle around one more time here. Okay, coming around here. Let's see if we can get that plane out. Wind's starting to pick up. Going to be a little bit challenging for Wings of Theseus here. Let's see. Come on. Oh, a little bit of a bounce. Another bounce. Third bounce. Fourth bounce. But back down in one piece. I tell you, the student that designed that landing gear needs an A. Hopefully I'm doing somebody solid out there. As Wings of Theseus completes mission number 1. Okay, recovery crews are out there on the runway, making sure that plane came back in one piece, and it looks to be okay. Ironically, Wings of Theseus lives to fly another day. Okay, so Chris, what team was that coming off? That was Santa Clara, right?
Santa Clara, number 25.
Number 25, and who do we got up next?
Up next is team number 28 from the University of Hong Kong.
All right.
They're just getting prepped up right now, finishing up their tech.
They're doing their tech inspection. Do they have a name for that plane?
Inspection. They're doing their
oh yeah, tech. The pre-flight. Yep, they're doing the pre-flight in the staging lanes. That's right. Now, do we have a name, or it's just University of Hong Kong?
Right now, it's the University of Hong Kong. I haven't had a chance to talk to them yet.
Okay.
I'll get up there in a second.
All right. Cool. Well, we'll have a name for that plane. University of Hong Kong taking the runway here. Okay, what's the name?
So Hong Kong's plane name is Griffin.
Griffin, all right, I like it. Good name. So University of Hong Kong, once again, we got a forward engine, we got tricycle landing gear, but they seem to have fairings over the landing gear. Taking some hints from a Cessna there. And we got an overhead wing on this design. The wing is above the fuselage. Most of the planes that we've seen here today have a under wing design. All right. And once again, when I say University of Hong Kong, I mean University of Hong Kong. This is an international competition. We have teams from 15 countries, 1,200 students here, 98 teams total. There we go, University of Hong Kong, getting ready to do mission 1. Once again, mission 1 basically entails going around our oval track, but the key is that on the back stretch of this track, we have the teams have to negotiate a 360-degree turn, and then have to go down to turn 3 and 4, turn around and come back over the main start-finish line. All right, pilots ready to go, engines are on. There we go, we got rotation up in the air. University of Hong Kong with Griffin is flying. Now, the University of Hong Kong's plane is a little bit smaller, so they seem to be really utilizing power to weight here. That's a tinier plane than what we've seen. Tinier plane gives you higher power to weight. Should be able to power through that headwind a lot better. Plane does the 360-degree turn, no problem. Circling around through 3 and 4, it does not care about that headwind. That plane is flying perfect. Okay, they've completed lap 1, Griffin. Lap 1, 1 lap down. 2 more to go. Oh, a little bit of a gust of wind through turn 1 and 2 there. Plane seems to have handled it. They're through that 360-degree turn on the backstretch of our track. Down to turn 3 and 4, turning it around. Let's see if we can handle the headwind again. All right, that thing is nimble. Okay, that's lap 2. Once again, teams have to, for mission 1, teams have to complete 3 laps, and they have to do it in a certain amount of time. So from, proverbial wheels up to wheels back down, you got to do it in a certain time limit. That doesn't seem to be a problem for the University of Hong Kong with Griffin here. That thing is cutting through the air. Okay, negotiating the roll on the final lap into turn 3 and 4. Circling around. Oh no, the pilot's hot dogging. Doing the aileron rolls and back into a reverse, going up in the air, doing another reverse inverted loop. Coming back down out of the loop. Oh, now they're just showing off. Circling around here for approach and landing. Now, once again, that overhead design with that power to weight makes it very nimble, like a Cessna. I'm not sure a Cessna can do that. Maybe an Aerobat, but they touch back down. Griffin back down on the ground after doing some aerobatics there. Showing off a little bit. Man. That was great. I'm not sure if that's part of the test flight regime. I don't think it is, but still cool to see nonetheless. Okay, so Chris, that was University of Hong Kong with Griffin. Who do we got up next?
Up next is team number 20. I can't remember my own handwriting. From the Washington University in St. Louis, flying their plane Side Duck.
Side Duck. Oh, got to catch them all here with Side Duck.
And that's team number 26.
Team number 26. Okay. So once again, we got, Chris, which one is it?
Washington University in St. Louis coming up with Side Duck.
Side Duck, all right, here we go. And as expected, they have Side Duck on their winglets. All right. Okay, this is University of Washington at St. Louis with Side Duck here, taken out to the runway. So once again, they're using a low wing design. Low wing design here with tricycle landing gear. It's interesting to see the different design decisions that these teams have come up with here. Team making sure they're positioned into the right direction here. Take off from our main straight. All right. Okay, ground crew's putting the fuses in to activate the plane. Let's see what we got. Now these planes do need to utilize a kill switch. You have to use You have to use a blade fuse to be able to turn the plane on and off. Okay, ground crew's vacating the premises here as SciDuck's about to take to the skies. For you Washington at St. Louis here with their SciDuck plane. Okay, the engine's on, here we go. The headwind immediately takes SciDuck up into the sky. All right. SciDuck's turning around, trying to negotiate turn 1 and 2. We got a good signal from the judge. They went through 1 and 2. Turning around onto the back stretch here. Now they're gonna have to do the 360-degree roll. Plane's executing the roll, but they got some gusty winds. But SciDuck is negotiating it, no problem. Okay, circling around 3 and 4 into the headwind. Really powering against that headwind there. Once again, we have a pretty bad headwind coming out of wind coming out of the south here, and that makes a headwind for the front stretch of the track here. The track's more or less an oval. You have to turn 1 and 2 down one end here, and when you come out of 2, you're going to get a tailwind. So because the wind's at the back of the plane, the airspeed increases. Oh, she's getting a little shaky. She's getting a little shaky, a little bit lower altitude. That's what I mean about these teams trying to keep these planes up in the air. It seems to have missed, SciDuck seems to have missed the roll, and it's going down the runway, and it went through 3 and 4. Ooh. The plane seems to have landed and touched down way beyond 3 and 4. That can't be what they want to see. Yeah, so while they're going to have to go, we have to clear the plane from the runway. We're going to take a quick break here while that plane gets recovered. We have to make sure one team gets off the track before the next team gets on. So once again, this is the 2026 AIAA Design, Build, Fly competition. We'll be back momentarily. Okay, we're back on commentary here. Sorry about the delay, folks. We have the Aerospace and Aviation University of Bangladesh. It's team number 30 with the Phoenix. Phoenix is now moving on to its second lap here. Going into the 360-degree turn. Down into turn number 4. We have a nasty headwind here coming across the main straight here. So when they come out of 4, they're going into a pretty bad headwind that's really going to slow the plane down. Well, the ground speed, that is. But then again, coming down on the main straight, going into turn 1 and 2, you have a tailwind. Conversely, on the back stretch of the track, that tailwind's going to increase ground speed because the wind's going to blow the plane. It's going to blow the plane forward. So we got some pretty tricky and challenging conditions here at the AIAA 2026 Design Build Fly competition. Once again, this is team number 30. This is the Aerospace and Aviation University of Bangladesh. This is an international competition. We have teams from 15 countries, 1,200 students, 98 teams throughout the weekend, and each one of them needs to perform 3 missions. This is the first mission for team 30 here for the Phoenix. Oh, that wind's really pushing that plane around as they come in for land. Try to come in on approach for a landing. Mission number 1 is basically a flight test of the vehicle, making sure that we can do what you see here. See the thing fly around. You got to complete 3 laps on our test track, and then you got to bring the plane down. You got to do it in a certain amount of time. And as the Phoenix spreads its wings into the wind, trying to come down for a landing here. Let's see. There we go. Phoenix touches down. Now that was the first of 3 missions that each one of these teams need to do. Mission number 1 is the flight test. Mission number 2 is moving cargo and passengers around. And we're not putting people on these planes. We have rubber ducks and hockey pucks. Hockey pucks being cargo, rubber ducks being your passengers. Now that's mission 2 for these teams, and then mission 3 is towing a banner around. So right now what we're seeing mostly is just mission 1 from these teams, just the flight test, make sure the vehicle works, make sure it's ready to do mission 2 and mission 3. You can't go to mission 2 without mission 1. You have to make sure the plane flies before you put people on it. Probably, rubber ducks, probably a good idea, I think. I think that would be nice. So as the Phoenix vacates the runway, Chris, who do we got next?
Up next, we've got team number 34 from the University of Akron flying their plane, the RU Express.
The RU Express. These names are great. All right, University of Akron with the RU Express. That's team number 34 here, getting ready to go. Now, once again, University of Akron opted for a tricycle landing gear design here with a low center, more or less mid-plane wing. That's going to make takeoff and landing a little bit easier for the vehicle because it's able to rotate when it's on the runway here. Team's moving out there to put the RU Express into position. Oh, uh-oh. Just quick little bit of weather update. It looks like I'm feeling some raindrops here on the flight line. Oh no. Got some raindrops coming in on the flight line here. We'll see. We'll see how this transpires. Now, Chris, I do have a question for you. You said that they could fly in the rain, right?
I believe they do fly in the rain.
Oh boy, the rain and the wind's going to make for some really tricky conditions.
Get to this competition.
Yeah,
like
that's right.
250 flights over the next 3
days. Yeah, exactly. I was doing the math out. Each team got to do 3 missions. We have 98 teams. There we go. This is going to be very challenging flying in this rain, but let's see what they can do. So
maybe Mother Nature will take a little care on us and not part the rain away from us.
Maybe pity, I don't know. It might be pity. Yeah, absolutely. All right, so we got University of Akron here with the RU Express. That's team number 34. Taken to the skies here. All right, RU is positioned on the runway, ready to go. Pilot's ready to go. Fuse is on the plane. Oh, wind's blowing that plane back a little bit. That's what I mean about that headwind. They got to get going here. You got to get going or else it's going to take off. There we go, RU Express rotating up into the air. All right, first turn that the Roo Express is gonna have to negotiate here as the headwind takes that thing way up into the sky. Turning around here through 1 and 2. It's a 180-degree turn, combined 1 and 2. Now we have the 360-degree turn on the backstretch of the track. But coming off of 2, you got a very, very, very tricky tailwind to deal with. It looks like Roo Express is handling it pretty well. Going down to turn 3 into turn 4, back into the headwind here. So Roo Express is coming around back through the main straight to complete its first lap of 3 that's required for Mission 1 completion criteria. Roo Express really challenging that headwind there. But she does seem to be pretty aerodynamically stable. Okay, turning around through 1 and 2, back into the tailwind. This is where ground speed really, really increases. Doing that turn. Backstretch turn, negotiated perfectly from U Akron here. Okay, turning through 3 and 4, back into that headwind. Okay, I do believe they got 1 more lap for University of Akron here with the Roo Express attempting to complete Mission 1 here. We do have some ominous clouds in the background here. I do believe I felt a little bit of raindrops here. They're turning around through 1 and 2. Coming back, we got a tailwind, ground speed increase. Going into the 360-degree turn. Seems to negotiate it just fine. Just fine. Coming into 3 and 4. Circling around 3 and 4. Back into the headwind. Okay, now they've completed all the laps that they need to do. Let's see how this pilot's going to put this plane back out onto the runway. Come down, got a good approach. Pilot chooses to go around, not good enough. Circling around. Once again, you can't just sit there and circle around infinitely on these. This is a timed mission. You have to get it done in a certain criteria time. And that includes getting the plane down to wheel stop. The headwind really, really blowing into the Roo Express there. Okay. Roo Express bringing the plane down. This is where that tricycle gear is really favored. They can really get the plane to rotate next to the runway. You can come in with a nice, easy approach. That headwind really wanted to keep that plane up in the air, but U Akron nails it with Roo Express. Well done. Well done. Okay. All right. Well, as University of Akron wraps up Mission 1 with the Roo Express, I do believe we've seen lightning in the area and we are in the middle of a runway. So we're gonna have to hit pause on this mission right now. We're gonna have to pause it. We can deal with rain. I don't feel like becoming a lightning rod today. I'm pretty sure I'm not a flux capacitor. Chris, are you a flux capacitor?
Not at all.
No, we do not want 1.21 gigawatts right now. So we're gonna put the competition on pause here, but there's still plenty more action here from the 2026 AIAA Design, Build, and Fly competition here in Wichita, Kansas. So we will see you soon. But those clouds over there are very angry, so I'm gonna get out of Dodge.
At General Atomics, not only do we make remotely piloted aircraft, we engineer innovation. For over 30 years, our Predator, Reaper, Gray Eagle, and Avenger aircraft have offered long endurance, flight-proven performance, and versatility. Today, we continue to develop and manufacture state-of-the-art, remotely piloted aircraft, tactical reconnaissance radars, and surveillance systems for the U.S. Department of Defense and many of its allies across the globe. Electromagnetic Systems is a world leader in applying advanced technologies to launch and recover aircraft aboard carriers, as well as transforming innovative concepts in breakthrough surveillance and electric weapons systems. Our scalable satellite platforms support defense, civil, commercial, and academic mission requirements. From underwater to space, we support the future warfighting force. Since the dawn of the atomic age, General Atomics has advanced the full spectrum of science and technology. From nuclear energy and defense to medicine and high-performance computing. Because of our people, we continue to leave a legacy of exploration and innovation. Tasked to produce the center solenoid for the International ITER experiment, General Atomics has been entrusted to develop the world's most powerful superconducting electromagnet. Perfecting nuclear fusion in this lab demonstrates the feasibility of fusion power, a potentially limitless source of clean energy. With the freedom to explore, General Atomics delivers transformational technologies for the world. Innovation made real.
So my main project this summer has been working on interceptor reliability. What we're doing is we're trying to make it so that the battery on our interceptor can be hot swapped in the field without requiring additional calibration. So this is our flight cage. This is where we do all of our testing and preliminary flights for the drones. This is our dyno. This is where we secure the drone so that when we spin up the motors, it doesn't go anywhere. All right, so I'm running our interceptor on the motor dyno. What we're doing is it spins the motors, which spins the propellers up, and then from there it collects the data of what the motor offset values are, and then it calibrates it so that our interceptor can have its optimal performance. Working at Anduril is different than working at any other company, mainly because of the autonomy I have as an intern. I feel really empowered by my mentor and my manager to kind of do what I need to do in order to get my work done that week. It's also a lot different than other companies because I can see how my work as an intern over the summer directly impacts the company as a whole.
In aerospace, losing a major contract doesn't just mean missing revenue. It can shutter an entire division. Billions in potential business, gone. Because you don't get second chances to prove your design works. Traditional advanced design forces you to choose between speed and fidelity when both are critical. NTOP changes everything. Explore hundreds of design variants with high-fidelity physics in the same time as it used to take for basic estimates. With implicit modeling, you can create robust parametric models that never break, so you can quickly generate any possible configuration of your design and get near real-time performance calculations that enable deep trade space exploration and generate high-quality performance data at a pace aligned with project timelines. Arrive at design reviews with comprehensive trade-off analysis instead of rough approximations. Because in a world where billion-dollar contracts are won on technical credibility, low-fidelity insight isn't good enough. When you're asked tough questions, you'll have real answers backed by real data. NTOP, design with confidence.
We are scientists and engineers. We are technicians and thought leaders. Collaborative, inspiring, innovative. Advancing aerospace and defense with a bold vision for the future. We are here to connect and protect the world, powered by purpose and driven to make a difference. We believe no challenge is too great, no question too big, no answer out of reach. We believe in pushing the boundaries of known science to meet the needs of the future. We believe in the power of people, the strength of community, and the importance of freedom. With passion and purpose, we shape the next era of aerospace and defense to create possibilities for better tomorrows. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX.
over to you.
Sounds good.
Okay, we're back here at the 2026 AIAA Design Build Fly competition here, and we are currently in a little bit of a weather delay. Mother Nature's not too happy with us right now. We're going to be in the weather delay for a little bit, but we are going to be out here in the hangar interviewing teams. So I have Andrew here from Worcester Polytech, right?
Yes.
Okay, so what's the name of that plane?
So that is the Goat Force One. Our school mascot is a goat, so Goat Force One.
Goat Force. I love it. I love it. And you guys are about to go to ground mission, right?
Yeah, we're about to do ground mission.
Okay, so what is ground mission? What's that part of the competition?
So ground mission is where you have to load your payload as fast as possible, unload your payload as fast as possible, and then attach your banner. And then the lowest time is the one that gets the highest points.
And there's like a meta to this too. Like if it's either flying or you want to do ground loading. So what's the benefits of doing ground loading versus flying?
So some teams built their airplane to have maximum payload, which of course is going to take longer to load.
Yeah,
so like
absolutely.
the Argentinian team has 100 ducks in their plane.
I mean, yeah, it's it's cool plane.
That takes a while. So we thought we'd take a different route, have the absolute minimum payload possible to just get as fast as possible.
Yeah, okay.
So we're doing 3 ducks and 1 puck. And then what we also did is we have a banner that is the minimum size. So it's easiest to load.
Okay. So, I mean, there's a method to that madness, keeping, if you're doing engineering, you got to do what a customer wants, right? They said 3 ducks, 1 puck. That's what you're going to do, right? That's the design. It's pretty straightforward stuff, right? Like, okay, that's cool. So you get to see kind of a little bit of a meta going on here with the different strategies that they do here. Now, I mean, you guys still got to do mission 1 though, right? You still have to do that, yeah?
Yep. So we're currently number 46 in flight for mission 1, and they stopped at 48. So we're kind of glad that they stopped a little early for the weather.
Yep.
Gives us time to do the ground mission in case we crash.
Okay. So now, are you guys ready to do this ground mission? Are we ready to move? Yeah. All right. Let's. Are you guys gonna head over there now?
Yeah. Are we ready?
Keep going, but we're ready.
We're ready next.
All right. Okay. Well, when you guys move, we'll move with you for now.
Right.
So once again, we're at the AIAA 2026 Design Build Fly competition here. We're going to follow WPI into the mission. We were showing the air missions a little bit earlier, right? And now we're going to show the ground side of this, because there is a 4th mission. The 4th mission is see how quickly you can load and unload cargo. So that's what we're going to do here in a moment when they are getting ready to go. So once again, we are in a little bit of a weather delay right now.
Going to get your attention, please, for just a second.
See, I told you.
I guess the weather's starting to turn nasty on us, and there is a large hail warning in the area. So we want to make sure everybody stays inside and not get hit with hail. That would be a really bad thing. So if you have any of your teammates or friends that are outside, they probably pay attention to the weather, but you probably ought to start making your way inside just to be safe. It lasts until 4 o'clock, and then hopefully it'll all blow through. We'll be done with it by then.
Well, what he said. What he said. I was going to say all of that, I swear.
One thing.
One more thing.
It's not quite yet. It doesn't start for a little while, but just giving you a heads up that between 3 and 4 is when they predict the hail to be bad. So just keep an eye out on the weather and make sure you get inside when it starts looking bad. Thanks.
Okay, don't get hit by hail. That is part of the lessons here at the Design, Build, and Fly competition. No, we're dealing with some nasty weather, guys. So we're just down here in the pit. We're with all the other teams right now. We're gonna see what we can do. We're waiting for them to move over to the ground mission, and then we're gonna go from there. But yeah, that's not the best weather update to get, I guess. But hey, Mother Nature's gonna Mother Nature, right? That's what's gonna happen. Okay, once again, we are in a weather delay. This is the AIAA Design, Build, Fly competition here in Wichita, Kansas, and the weather is not cooperating with us. But we'll be around, and we'll be here. We're going to interview teams. We're going to learn about some planes, and hopefully, maybe later, see some planes fly. And I'll knock on wood. So right now, we're just waiting. We're following Worcester Polytech around, and I can say Worcester correctly because I'm from there. All right. Well, Boston, that's close. The Worcester people just said, no, it's not. But we're going to follow them over to do their ground mission here. Once again, there are the 3 flying missions in this competition. So, you know, 1 is doing the flight test, which is what we saw a little bit earlier in the stream. 2 is loading cargo and flying around, and 3 is towing a banner around. But there is a 4th mission. 4th mission is how quickly you can load and unload your cargo. So, when these guys are ready to go, we're going to move over there. You can see them, they're testing the control surfaces on the plane. She's wiggling. Oh, she's wiggling.
So we're putting our names right now.
Cool.
Maybe next.
Right on, guys. Excellent. Okay, so wait a minute. Who's the structures person? You're the structures person, Andrew. So why the split? Why do a split? What was the design decision there?
Kind of looks cool.
Dude, you know what, man? If it looks cool, that's right. Like,
while we were designing, we wanted to be able to move the fuselage back and forth.
Yep.
So we did not want to fix the tail to it. So we have our wing and our tail set up as one configuration, and the fuselage we could design that however we wanted. We could place it wherever. So originally, when we did our fuselage, we had it shorter, a little bit farther back.
Yep.
But then we were tail heavy, so we needed to move it forward.
Yep.
And since we made it so the fuselage wasn't structurally important, we were able to just move it a little more forward.
okay, so you were doing some kind of design iteration here over time, right? Because you have to figure out how much the motors, the mass of the motors, et cetera, et cetera. So that's actually really smart. You
And we
configured
wanted,
it.
for ground mission, we wanted to keep the ducts to load. We wanted to keep the ducts loading in from the top, so you can put them in really quick.
There you go.
Because if our fuselage was under our wing, you'd have to be
wing loading
fumbling on the side of the wing, and that just would have been slower.
It's like the cargo planes that could just open up the nose. You put it right in. There you go.
That's
cool.
possible.
That's
Then our puck loads in from the side, just like this.
Yep.
This door opens up, slot just for the puck.
Vertical stowage. I like it.
Yep.
That's cool.
So we're also using basically the dimensions of the fuselage is basically just the dimensions of the puck. So we were able to fit everything in. So
okay. All right. So yeah, you're iterating right around your requirements. That's great, dude. That's what you should be doing, right? That's what this is all about. Okay, who's the prop lead? Who's propulsion? Come on, man. I need to talk to you real quick. I just picked Andrew's bread. I got to talk to you. So you're what's your name?
My name's Garrett.
Garrett. So you're the propulsion guy for Y2 Motors.
It was a really early decision, to be honest.
Yeah.
Rule of cool. We thought it was pretty cool.
You know what? That's fine. That's totally okay. I get it.
Went with 2, and we kind of worked from there. That was the first decision.
Sweet. Because if you're configuring the fuselage for a hockey puck, you can have as many engines as you want and let it go, right? Yeah, there you go.
2's better than 1.
So, do you know what the power to weight on thrust to weight is on this thing? Is she going to go?
It's real high.
Good.
We're sitting right around 2.2 to 2. Yeah. So,
okay. All right.
We went high. We wanted to prioritize speed.
Yeah.
Because we're minimizing the number of passengers and cargo we carry.
Yep.
We want to do a maximum number of laps.
Okay.
So if we can go fast, we can do that.
So you got it's like a Cessna Caravan going on here. You just got to go quick. Load up cargo, get out. Cool. That's awesome, dudes. All right. This is great, dude. This is a cool design. I love, rule of cool is totally fine. All right. I will say that right now. Rule of cool is totally a viable solution as long as your driving requirements, as long as your requirements are met, man. Right?
And it's gotta go fast to be cool.
Yeah.
I mean, come on.
See, I like you. You're awesome, Garrett. That's sweet. So, okay, do you have individual V-stabs back there? Is the wiring going on either side? Do you split the wiring here to go to there?
Yeah. So the rudders are actually on a Y-split. They're powered by the same connection on the receiver there.
Yeah.
So they're connected. They'll go in tandem, and then our elevator is also running down the boom.
Yeah. So you have 2 wires going over there and 1 over there for the servos. That's cool, man. Right on. Excellent. Sweet. All right. Well, you guys are going to get ready for ground mission. I'm just waiting for them to say you're good to go over there. I'm going to be in your... Yeah. All good. Cool. So you guys are saying you had different leads, right? So you're the propulsion guy. You're the structures guy. Okay.
Team lead.
Come here. I need you for a second. So you are?
I'm Rachel.
Rachel? Okay, so you're the team lead. So did you make the design decision to make the fuselage around a hockey puck?
We all made the team decision.
That's cool.
Yeah,
Excellent.
we vote on everything as a team.
All right.
So that way it's a completely involved decision.
Cool. That's excellent. This is great. So okay, your wing. Is there a specific design to that wing? Is it a certain airfoil, or you're just like, no, really cool, that we want that wing?
What was the airfoil? 23015 is our airfoil.
NACA, gotcha. NACA design. All right,
Yeah, NACA
cool.
design. Spaced out all our ribs accordingly.
There you go. That's awesome. You're not worried about the structure going anywhere in between here? Like on the main wing? You had to build more into the wing box because you're using the split back, right?
Yeah, we used different types of wood. We've got basswood and plywood for everything that needs to carry our structural weight.
Cool. That's awesome. All right.
All right, we're heading over to the ground
Well,
mission.
we're going to follow you around and we'll see. Gotta get loose and ready. So we're gonna follow them over to the ground mission. We're gonna see how they go. There's a lot going on here. There's a lot of different planes. Nice shirt, man.
Thanks. Wonder where I got it.
You see that? Nice shirt. All right. I guess we have fans? Well, there's probably not me. There's probably everybody else. All right, so they're going into ground mission now.
They saying, hey, we're gonna
Following the same people you are.
Yep.
So, is that something that you're flying? Okay, well, that's
All right, so where we're at right now is the fourth part of this competition. This is the ground mission. The ground mission is basically showing us it's part of the competition. This can get you points if you want to go this route. It's how quickly you can put cargo in and out of the plane and get the banner attached. So what our friends that we just talked to over at WPI, what they're doing is getting their plane ready to go for this ground mission. So they're talking to the judges, right? And this represents the fourth part of this. Like, it's not all just flying, right? Every plane, the AIAA has denoted ground requirements too, just like any other plane. Like, what are ground requirements, just in case anybody wants to know? Like, okay, an easy one would be, is it a seaplane or is it not a seaplane? There's a little bit of a different design requirement there if you need pontoons on the bottom. Now, there's no seaplanes in today's competition, I don't think. I mean, it depends on the weather. We got to be very careful here. It depends on the weather. But, you know, optimizing for the ground mission means that maybe you don't need to carry as much cargo for your flight missions, right? So that's what they're going through right now here. Let's see how they turn out.
Second section, team 94, University of Maryland, Baltimore County, last call.
You're fine. Right now.
Just that one and
We have to take off the servo arm. We have to.
We also have to take the servo horn. We have to also unlike.
We could not stop the servo. We can't take the servo off because that's a pain in the wire. I guess we'll wait and see. The removable portion will just be nice. Yeah. Yeah, that's good. Yeah. Oh yeah, you want to solve the process? Yeah.
And I'm like, how terrible that was.
Yeah.
This structure is for mission 3. It's not removable as is for going to travel mission, so they need to have
So we can just remove this structure here. So everything except for the servo. The servo can stay, everything else needs to come off. Okay.
Got it. Okay. So,
when would we not have time?
yeah, so if your wheels come off the ground for whatever reason, if you jostle it, that's fine, but if you accidentally lift the aircraft, that's a fail. Okay. If the banner deploys or doesn't deploy, that's a fail. If you drop it without deploying, that's a fail. Those are the main ones. If you don't fit all your ducks that are in your duck inspection sheet, that would be a fail. Okay.
I'm not going to be able to get this all on.
This changes a lot of things.
I'm going to have to do this. So we're going to go from, it's going to go from like 17 seconds to like probably 2 minutes. So, yeah.
I need the FX again.
You need the to me. Yeah. It's going to be this and the servo horn.
And the servo horn?
Yeah. Servo horn is going to have to go in a pretty similar spot because it's programmed at specific intervals. So know that angle. Know that angle. Close enough. Oh,
we're allowed to use power tools.
Don't use power tools. You can't fit the drill in this anyway. But that's just that's more risk of breaking something. I don't remember it.
Because remember, originally we were going to have this whole fuselage just take it out and put in a new one.
Yeah, and then it said you can't change the configurations.
Then take another Canon camera. Like, I want to take a stop. HMI SCI. The hangar.
Are you filming?
Hey everybody, I wanted to just give you a quick update on the weather. We are continuously monitoring the weather for anything that might affect the competition. We did want to make everybody aware that if a tornado warning is issued, we will ask everybody to leave the property and seek shelter. That has not been issued, but we will continue to monitor it and we'll let you know if anything changes. We did also want to make you aware that a high wind warning has been issued. We're good. It will get pretty windy in here around the property. Take whatever precautions you need.
All right, cool.
Stuff set out on the,
tell me when we're good.
out on the lawn. You probably
Okay, we're good.
got picked up.
All right, so Nate, you just went through ground mission. What happened?
So basically, we had an original idea of what we were going to go in and do,
The ground
and
mission
we
is
just
still
found
open,
out
so if you,
our original
if you want
plan
to
is not up to
continue
rules.
to participate in the
So
ground
you're
mission,
supposed
we
to take
encourage
out
you to do that.
everything
There's a sign-up
associated
sheet.
with ground mission and put it on during the ground mission. We had something that's fixed on there permanently, so you'd have to undo a bunch of screws to redo it to get to it.
Just to
yeah,
clarify too,
right? Yeah.
you
So
guys
right now,
need to be ready
we're
to
gonna
go.
go
Like, we
and
don't
probably
know if there will
between
be
now and tomorrow, we're gonna 3D print a new
But
part
when
that
that
you can just
warning is
slip,
issued,
slide
you
in,
need
and
to
click
be
in.
ready to just
So instead
leave.
of just giving up,
So
we're
it's
just gonna go
probably behooves you
and go to Wichita,
start
or go
getting
to
things
University of
wrapped up and sorted
Wichita,
out
and we're gonna
so
use their
that you
3D
can't
printer to
just
build
leave
a
at
new
moment's
part.
notice.
That's the spirit, man. That's how you get it done.
We'll let you
That's
know
sick.
as soon as we
All
get
right,
more.
dude. Thanks, man. I
No
appreciate
problem.
it. We'll follow up later. We'll see how this
Sounds good.
goes.
Yeah, hopefully by tomorrow it should be done.
All right. So that was Worcester Polytech there, with trying to do ground mission, but
Okay, everybody.
judges weren't having the rules. They weren't having it.
Move your hands.
I think they can
Okay.
hear us.
What I said is that we are continuously monitoring the weather. Right now, there is no tornado warning, but if a tornado warning were to be issued, we need you to leave the property and seek shelter. There is no shelter here for you. When that happens, you need to be ready to leave. So, it behooves you now, unless you're going to do ground mission or other things, to start packing up and be ready to leave in that eventuality. Again, that has not happened, but we want you to be ready for it. We are continuing to monitor and we'll let you know if anything changes. Thank you.
Monitoring the situation is important. You know. So, yeah, right. So, okay. So this is the 2026 AIAA Design, Build, and Fly competition, but we're under a little bit of a weather warning. We might go Bill Pullman here and go release Dorothy. We don't know. We'll see. We'll see here. But yeah, we're down in the pit. I'm gonna go find more people to interview. But yeah, we're having a good time here. We don't know. The weather's being a little wishy-washy, but we'll figure it out as we go. Once again, this is 2026 AIAA Design, Build, and Fly competition. We'll be back in a little bit. that's all. Okay, welcome back to the AIAA 2026 Design Build Fly competition. Unfortunately, the weather is not cooperating with us, but that doesn't mean that there isn't action happening here in the hangar. So I'm going to give you guys what you want. We've been paying attention, and we're going to tell you we're going to tell you what's going on inside of the hangar. So one of the things here, come on with me. One of the things that's been going on is the fourth mission. There's 3 missions for that include flying planes around, but the 4th mission is the ground mission. I was talking to you guys about it a little bit earlier, but I'm going to try to go down here and see if we can get some of the ground mission judges to come and tell us what they're all about. So let's see if we can get over here. Taylor. So.
Okay, checking note please.
Okay, no, you look great. Okay, so you're doing the ground missions. You're the judge for the ground missions,
Yes.
right? Cool.
Yes, I am one of 3 judges for the ground missions.
Okay, what are the ground missions for the people at home?
Right, so the ground mission you need to convert from your mission 2 configuration into your mission 3 configuration. So you start with the plane empty, you have to load all of your pucks and all of your ducks into the plane, then you have to unload all of your ducks and all of your pucks back out of the plane, install your banner, and then we have them lift up the plane and show that they can deploy a banner and then fully drop it.
And that's timed, right?
That's all timed.
That's all timed. Okay, so how do you give points to this? Like, is it just whoever has the fastest time gets the most points? How does that work?
So you're compared against the fastest team.
Oh.
So it is the fastest team divided by your time. So the fastest team will get a score of 1.
Oh, okay.
And then you will be under 1 for how much slower you are than them. So it'll change throughout the weekend as the top team changes.
Okay, and do we have anybody lined up for those ground missions or no?
Looks like we're getting somebody ready here in a couple minutes. They had a couple changes on their plane, so we should have someone here soon.
Okay, cool. I think we should get something out of you. Cool with that?
Yeah.
We see? Oh, that's going to be sick. All right, cool. So the ground missions happen right here, yeah?
Yes.
So is the white box, like it has to be in the white box? Like,
yeah, so their plane has to be in the white box. They have to start outside of the box.
Yeah.
Their time starts once they step in, do all their work,
okay.
time stops, step back out.
And they have to be hands off the plane has to
Yes.
stay there. Okay, all right, cool. Great. So we're just going to wait on the team here for
All
a second.
right.
You know, everything is in flex here, right, all the time. So we're going to wait here for a moment, and when the other team gets here, we'll start watching some fun ground missions. That should be good. So wait. Actually, one more thing real quick. Pucks and ducks?
Pucks and ducks.
Okay. That's the cargo, and those are the passengers. Am I
Yes.
understanding this right?
Yep.
Okay, so I'm
So there's
noticing...
some weird ones. You got Minecraft duck.
All right.
We've got ice cream sundae duck. They don't get to pick their ducks.
They don't.
Probably 50 options. We have a bucket. We pick their ducks, so they couldn't have planned for sizing. Some of them are a little wider, some of them are a little taller.
Well,
This guy was too tall, so he needed an emergency surgery. Some of them are a little wider. I've heard this guy's pretty wide, so they have to design their seats to be able to fit the tallest and the widest ducks. They don't know what they're going to get.
Okay, so I've seen some planes that are carrying more ducks than others. I know the minimum requirement is 3 ducks and 1 puck, right?
Yes, so the minimum requirement is a ratio. You have to have at least 3 ducks for every 1 puck.
Oh.
So if you're carrying 3 pucks, you need to carry at least 9 ducks.
Well, ducks got to have their luggage, right?
Exactly.
Okay, that makes sense. All right. Wait, what's going on behind me here?
We got a really big banner going
Wait a
behind
minute,
you, so
here.
don't back up.
I'm just going to move around
Shimmy
over
out.
here. All right. So, okay, why are some banners bigger than others? I've seen some, they're like a couple of different sizes here. Why is this one so big?
So they can fly a banner as long as they want, but it has to be a 5-to-1 ratio. So for every 5 feet of the length, it has to be at least 1 foot high. So when you get these really, really long banners, you start getting 5 to 6 to 7 feet tall as well. So this is going to go behind their plane, unfurled in the air while they fly.
For
it's huge.
an RC plane. Is that for the team that's coming up here?
No, that's a team going through tech inspections. That's probably one of those two guys.
Oh, okay.
So they'll roll it all back up, and they'll have to deploy it while they fly. And then before they land, they're going to have to drop the whole mechanism down.
Okay. All right. You may or may not know this. This isn't so much ground mission, but like, do you get bigger points for a bigger banner?
Yes.
Okay. All right. See, that makes a lot more sense.
Yeah. So mission 1 is just proving that your plane can fly
Test
and is
flying,
safe.
right? Yep.
Mission 2 is ducks and pucks.
Ducks and pucks.
And then mission 3 is the banner.
Okay. All right.
So we might see, if we have a really good day tomorrow, we might see our first mission 3 tomorrow. More than likely, we'll see our first mission 3 on Sunday.
Knock on wood.
Weather is not really getting along with us,
No,
but we'll
it's
see.
got a little rowdy out there. I don't know if you saw it.
It was a little noisy earlier.
All right. Do we have a team up here, Taylor?
I'm going to yell at them.
All right, cool. You yell at them.
You guys ready? Beautiful. How many pucks are there?
They're choosing the pucks and ducks.
3 pucks. Would you like to pick 10 ducks?
Oh, sure.
Into the bin.
Sure. All right. Into here?
Yep.
All right. Okay, let's see what we got. I'm in charge of picking the ducks now. Okay, we'll take giraffe duck. That's fine. We'll take army duck. I'm trying to be nice. Soccer duck. Let me see. Where's Minecraft duck? Minecraft duck. We like Minecraft.
Or Indiana Jones duck.
Belongs in a museum. Okay, I'm giving him wide duck because I'm being mean, I guess. Is this cow duck?
7.
Got it. I have the traffic. Is this Batman duck? Ninja duck. All right, yep.
8.
You get ninja duck. And all right, let's go around here. Two more. All right, surfer duck. Yeah, you get surfer duck. And what are you?
Butterfly. Weird butterfly.
Weird butterfly, not an alien duck? All right.
10. All right.
10. All right, there we go. Let's see what we got.
Okay, put it wherever you want. 3 and 10. Yes.
Okay, so they have to load up this cargo here. Let's see what happens.
Middle East Technical University.
We'll see.
Tech inspection.
Let's watch this.
You don't have a propulsion battery, right?
All right, if I can have everybody.
All right, they're getting ready for the ground.
Quick announcement.
Uh-oh, hold on. Quick announcement.
Can you guys in the back hear me? Wave your hand. We are under a lightning watch that will last until 5:30. Lightning warning. So
Hey, Peter, we need wire cutters. We have to cut this
that
off.
will persist until 5:30, which will really preclude any meaningful flights. So the flight line is being closed for the rest of the day. However, if you want to do ground mission or tech inspection, those will stay open until until 6 o'clock.
Okay, so guys, I don't know if you guys heard the PA. There's a lightning warning or watch in the area. Warning is different. So the flight line is going to be closed for the rest of the day.
Okay, the next 3 teams that are waiting for a range check, please come up to the scoring table with your airplane ready to go.
Okay.
Team 26, University of Kentucky, Paducah.
All right.
Team 27, University of Arkansas, and Team 23, University of Buffalo.
Okay.
Please see you up here at the scoring table, and we'll take you out to your range check.
So unfortunately, that means I don't think we're going to see anything flying for the rest of the day, but that's definitely going to happen tomorrow, and it's probably going to happen a lot. But that doesn't mean we aren't going to get in on the ground missions here.
We need a team name.
Yeah, this is St. Louis. Let me ask real quick. Okay, so this is St. Louis University up here, doing their ground mission here.
Have you seen any of these?
Actually, I got a better idea. You guys, real quick, is this yours doing the ground mission now? What university are you guys?
St. Louis University.
St. Louis University. That's the live stream that's going on here, so you can give a shout out if you want.
Yeah, shout out St. Louis University, Bro Bills. We did a great job at the NCAA tournament.
All right, yeah. Let's do it. All right. Thank you. Sorry to put you on the spot. I just wanted to know.
3, 2,
all right, here we go. Okay, it's loading up the ducks there. The ducks that we chose. I hope I gave them good ones. And once again, this is timed here. They got to load up all the cargo, load up all the ducks and cargo, and the ducks and the cargo have to be in a 3-to-1 ratio. So for every 3 ducks, you have to have 1 puck. And that really kind of opens up a couple of different design constraints for these things, right? Do you want to opt for more? You get more points if you have more ducks, but then again, you're making a heavier plane. You have more requirements for your design. There we go. With the puck sliding rail, all right. Uh-oh. I seem to be having a little bit of trouble with.
Oh, yeah.
Good call, a little bit of help from the team there. Once again, there's a white box around this. And there you go. Got some cheers. Oh, they are timed here, so all the cargo is loaded. You got to latch all the doors. The doors have to have a latching mechanism here. All right. Control surface checkout.
Your nose here and almost lift your close. Ready?
Okay.
3, 2, 1, go!
Send it. Okay, now it's just do the reverse operation here. And once again, this is the 4th mission here. Watching St. Louis University unload the cargo for the ground mission. You're graded against the team that goes the fastest. So whichever team goes the fastest, it's your score, their score divided by yours. So ideally, you want to be the fastest, because if you're not the fastest, then you're gonna get graded against the fastest. Losing some cargo there, but now what they have to do is reconfigure the vehicle to mission 3. That was mission 2, so that would have been flying the cargo mission here. Now you're retooling for mission 3. Mission 3 is the banner. Okay, that's the banner deployment mechanism on the back. Oh, they got to be careful. You can't have that gear leave the ground.
Is there anyone else in line for ground right now? Can I try again just from like the
Okay. Nose gear came up. Looks like their nose gear came up off the ground. Can't have that happen. So they're going to get another shot here. As long as there's nobody in queue, right? They're going to get another shot. But it's another shot for the second part. So the first part is loading the cargo. See how fast you do that. And the second part is unloading the cargo, getting your plane out of mission 2 configuration into mission 3 configuration. All right. And yeah, they. I guess they don't like that nose gear coming up off the ground. I'll have to ask Taylor about that.
I saw you hold it, and I was like, oh.
All right, SLU is going to have another attempt here.
So she put the propulsion battery in. So we offered for her to put her propulsion battery in, not plugged in. We don't want any spinning props in here.
No,
so that the
better.
nose is a little bit heavier.
So the gear
so
can't.
that it doesn't lift.
Yeah, gear can't come up off the ground.
So
then, yeah?
they're putting in their battery for ballast.
Okay.
And then we're going to try again.
All right, we're going to retime the whole thing.
Yep, we're going to start
All right.
over.
Cool. Thanks, Taylor. Yeah. Appreciate it. All right, there we go. Okay.
We should be fine.
Round 2.
Ready? 3, 2, 1, go!
Let's jam. Okay, there we go. Loading cargo. Those are the ducks that we picked out. I hope I give him good ones. Okay, all ducks are loaded. Now it's down to the pucks. Okay. We got 3 pucks loaded and out. All right. Control surface checkout.
Ready?
Okay.
3, 2, 1, go!
Okay, now it's unloading. It's doing the exact opposite and then reconfiguring the plane for mission 3. Mission 3 is the banner. This team's got to carry around a banner. If you look over onto the right a little bit towards the aft end of the plane, you can see the banner on the ground. But she has to add the banner deployment mechanism as well. But she can only do that once the cargo is unloaded. Okay, all ducks and all pucks are unloaded. Okay, banner deployment mechanism going on now. Once again, the gear cannot get off the ground. So what Taylor had them do is put their battery up in the front of the plane so the nose gear would not come up off the ground. Banner deployment mechanism is plugged in. Now the battery's not hooked up because as Taylor said, we don't want props spinning around in here. But it's good enough to weigh the front of the plane down that we can get a second attempt. There we go, rolling up the banner, loading it into the deployment mechanism. Looks like the banner's attached on some fishing line there. Okay, banner's almost rolled up. Spooling it up. Now we just got to attach it into that deployable system. Okay. All right, there we go. Loading the banner up. Okay, remember, once that banner's all loaded up, she has to leave the square, and that's when they call time. She's working with the pilot there that's outside of the box to make sure that the banner deployment mechanism is primed because they have to deploy. They have to show that they can do that. Okay, they're out of the box. Judges are comparing the time. Control surface checkout.
Do you want to lift it or do you want someone else to lift it? Okay, someone can help me lift it. EJ, you're going to have a plane coming here too.
Cool. Yep, got it, man. Just watch in front of you. All right, there's the deployment. We see it. All right. right, there we go. And that's ground missions.
Ground mission.
There you go. That was pretty cool. That was pretty cool. How'd they do? They do okay? They did good? Except for that front gear?
Yeah, well, the second one was clean.
That's good.
Yeah, that battery really helped them out. That nose gear didn't wobble at all the second time around. I think she actually tracked faster the whole time, so I think that second try was for the better overall.
Now, how lenient are you with the route? You just get...
Not at all.
Yeah.
So there's a really good Parks and Rec meme I think a lot of people know. I tell them, if I see light under your wheel, straight to jail.
Straight to jail.
Start over.
Yep.
So I've carried it through. We did it last year. We were merciless last year.
Oh.
We ruined a lot of kids' days last year with the wheel lifts. So they kind of knew this year that we were going to take it really, really seriously.
There you go.
We warn them. We do our best.
Yep.
And we let them retry as long as there's no one else in line. So they get another shot.
Cool, cool. All right. Do we have another ground mission coming in?
I don't see someone lined up yet. I'm hoping we'll have someone in soon, but I don't see anyone on deck yet. So maybe another adventure for you.
Cool. Thanks, Taylor. I appreciate your time.
Yeah, thank you.
All right. So come on this way a little bit. We don't want to get near them. All right, so that's the ground mission component of this. Once again, that's one of 4 different types of missions that the student teams are trying here at the AIAA 2026 Design, Build, and Fly competition. Once again, unfortunately, we don't really have... There's not a lot more action happening today. The reason why is because there's lightning. We're out on a runway. It's really flat. There's not a lot of things out there, and we're the tallest thing around. We do not want that. So with the lightning, we're not going to have much more action here today except for ground missions, but we will come back to you if we have more ground missions and more teams to interview here at the 2026 AIAA Design, Build, and Fly competition. We'll be back very soon.
the tools to be ready for industry. As a student, you do get exposure to the design-build flight. You're building a plane from scratch with the support of mentors. You're exposed to the problems that we need to solve at the moment. The AIAA helped me build that passion.
At General Atomics, not only do we make remotely piloted aircraft, we engineer innovation. For over 30 years, our Predator, Reaper, Gray Eagle, and Avenger aircraft have offered long endurance, flight-proven performance, and versatility. Today, we continue to develop and manufacture state-of-the-art, remotely piloted aircraft, tactical reconnaissance radars, and surveillance systems for the U.S. Department of Defense and many of its allies across the globe. Electromagnetic Systems is a world leader in applying advanced technologies to launch and recover aircraft aboard carriers, as well as transforming innovative concepts in breakthrough surveillance and electric weapons systems. Our scalable satellite platforms support defense, civil, commercial, and academic mission requirements. From underwater to space, we support the future warfighting force. Since the dawn of the atomic age, General Atomics has advanced the full spectrum of science and technology. From nuclear energy and defense to medicine and high-performance computing. Because of our people, we continue to leave a legacy of exploration and innovation. Tasked to produce the center solenoid for the International ITER experiment, General Atomics has been entrusted to develop the world's most powerful superconducting electromagnet. Perfecting nuclear fusion in this lab demonstrates the feasibility of fusion power, a potentially limitless source of clean energy. With the freedom to explore, General Atomics delivers transformational technologies for the world. Innovation made real.
So my main project this summer has been working on interceptor reliability. What we're doing is we're trying to make it so that the battery on our interceptor can be hot swapped in the field without requiring additional calibration. So this is our flight cage. This is where we do all of our testing and preliminary flights for the drones. This is our dyno. This is where we secure the drone so that when we spin up the motors, it doesn't go anywhere. All right, so I'm running our interceptor on the motor dyno. What we're doing is it spins the motors, which spins the propellers up, and then from there it collects the data of what the motor offset values are, and then it calibrates it so that our interceptor can have its optimal performance. Working at Andrew is different than working at any other company, mainly because of the autonomy I have as an intern. I feel really empowered by my mentor and my manager to kind of do what I need to do in order to get my work done that week. It's also a lot different than other companies because I can see how my work as an intern over the summer directly impacts the company as a whole.
In aerospace, losing a major contract doesn't just mean missing revenue. It can shutter an entire division. Billions in potential business, gone. Because you don't get second chances to prove your design works. Traditional advanced design forces you to choose between speed and fidelity when both are critical. NTOP changes everything. Explore hundreds of design variants with high-fidelity physics in the same time as it used to take for basic estimates. With implicit modeling, you can create robust parametric models that never break, so you can quickly generate any possible configuration of your design. And get near real-time performance calculations that enable deep trade space exploration and generate high-quality performance data at a pace aligned with project timelines. Arrive at design reviews with comprehensive trade-off analysis instead of rough approximations. Because in a world where billion-dollar contracts are won on technical credibility, low-fidelity insight isn't good enough. When you're asked tough questions, you'll have real answers backed by real data. NTOP, design with confidence.
We are scientists and engineers. We are technicians and thought leaders. Collaborative, inspiring, innovative. Advancing aerospace and defense with a bold vision for the future. We are here to connect and protect the world, powered by purpose and driven to make a difference. We believe no challenge is too great, no question too big, no answer out of reach. We believe in pushing the boundaries of known science to meet the needs of the future. We believe in the power of people, the strength of community, and the importance of freedom. With passion and purpose, we shape the next era of aerospace and defense to create possibilities for better tomorrows. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX.
Okay, we're going to wrap up day one here at the AIAA 2026 Design Build Fly competition. So, the weather kind of hosed us today. So I got Phil Butler here with me. Phil, how you doing?
Doing great.
So what happened with the weather today?
So, the weather kind of gave us a lot of problems today.
Yep.
We ended up having to close the flight line about 12:30. Just continuous kind of line of lightning and possibility of hail. That really slowed things down for us.
Yeah. So what do you think we got for the weather the next couple of days? Hopefully trending better?
So
the weather, you can't predict the future.
The weather for the next couple of days looks actually really excellent. Tomorrow we're looking at 50s to upper 60s. 9-mile-an-hour winds. That's like really ideal for the teams.
Right. Because
I think we'll be able to catch up quite a bit and let our teams get as many flights in as possible.
So we got a lot of mission grinding to do tomorrow. So that was Phil. Thank you for cluing us in on the weather. Really appreciate it.
You betcha.
We got another special guest to cap this stream off. Phil, thank you very much.
Yeah. Thank you.
Cool. Let me grab that back. We got another special guest here. We got Clay Maury here, the CEO of the AIAA, to help us cap off day one. Clay, how you feeling with day one? Good, bad?
Well, we're excited. I mean, the weather was a downer, but we're excited to have so many great teams here today. We really have an amazing set of competitors. It's 1,148 competitors, 89 teams, 15 countries, as far away as New South Wales in Australia, over 15,000 kilometers away, 9,000 miles. And we have 2 teams from Australia, you have 2 teams from Bangladesh. It's an amazing set of schools that are here, and we're really excited that the competitors are here and they've turned out.
Yeah, we had a great turnout. So who's the closest team, if you don't mind me asking?
Well, Wichita State, we're here in Wichita, Wichita State.
Right.
So we have 2 Kansas teams. We have KU, Rock Chalk Jayhawk. They're here, and the Shockers, Woo-Shock from Wichita State. I think it's going to be interesting tomorrow. The weather looks like it's going to be holding up. It's going to be better. A little cold in the morning.
Yep.
But I think we're going to have a bright, sunny day and see a lot of good flying.
All right. Well, there you have it. Right from the head honcho right there. That's Clay Maury, CEO of the AIAA. So I think that's going to wrap us up here for the AIAA Design, Build, and Fly competition here for day one. Fortunately, sometimes it goes a little slow. Sometimes the weather doesn't cooperate, but we have good weather trending over the next 2 days. So that's going to wrap it up for us. Thank you very much for watching, everybody. We will see you tomorrow at 8. We're going to start 8:30? 8:30. We'll see you tomorrow at 8:30 with a pilot's briefing, and we're going to jump right into more flights. We got more commentary. We got more missions. Still plenty of event left. So thank you very much for watching, and I hope everybody has a good night.